Now more than ever, innovative technologies are fueling change and sparking new ways of thinking. Collaboration between corporations and startups is key to staying at the forefront of these trends. However, finding the right startups can be expensive, time-consuming, and ineffective. But Plug and Play is here to help. As a corporate partner, you will gain access to a whole ecosystem of innovation. Discover startups that meet your tech interests. Stay updated on the latest trends and network with industry peers. We will help you during every stage of your innovation journey, no matter where you are and where you want to go. Get in touch today.
All right, ladies and gentlemen, welcome to our Semiconductor Deep Tech Day. This is our second official semiconductor event that we are having here in our Silicon Valley office after we started our semiconductor initiatives. Last time, it was in mid-March that we had Semiconductor Innovation Day, so I'm seeing so many of your familiar faces, but to just give you some more background of why we are here and what are we doing here. My name is Ruzbe. I'm leading semiconductor initiatives within Plug and Play, and it's really a pleasure and seeing you, all of the familiar faces as well as the new faces. This time, we are not just having startups. We have this pleasure of co-hosting our event with CEA and CEA Leti, and they are bringing also their latest R&D technologies, as you can see around the room. So it's a great opportunity to know what's going to be the next generation of the semiconductor R&D stuff. Just quickly going over agenda. I know we are a bit behind our schedule, but it's going to be fine. We are starting with a few minutes of introduction. We have a great keynote speaker. Then we are going to our deep tech buckets. Each of these deep tech buckets included R&D presentation from CEA and CEA experts. Then we are going to have some startups presenting on the same topics. And then for each of them separately, we are having a great fireside chat for you in the between of the two deep tech buckets. And at the end, we are having someone from French Chancellor. They are going to tell about US-France partnership as well as what's going on with the European Chips Act. And at the end, of course, we are finishing with the favorite part of French wine and cheese. So just to let you know what are we doing here at Plug and Play, I will go quickly over our introduction. We are the largest innovation platform in the world globally that we have about more than 50 offices, headquartered here in Silicon Valley. Our business and business plan has main three pillars. The first and most, the first one is venture capital. We are the most active VC in the world with having over 200 investment per year. In last year alone, we had 248, if I'm not mistaken. Another aspect of our business is accelerator programs that we are running over 60 industry TEM accelerator program on all of our locations. And of course, we are doing corporate innovation. With having more than 550 partners, no matter it's like their corporations or government entities, we are helping them with solving their innovation challenges. We are introducing them the startups in the topics that they are looking for. We are moving those introductions to the proof of concept and next stage of piloting and POCs. And of course, eventually our goal is to move them forward to the full scale implementation. I want to ask Saeed, or CEO, to come up on the stage. But before that, I would like to quickly show you guys a 3-minute video.
This is Startup Autobahn, Europe's best open innovation platform. I'm excited to see what the future of mobility looks like, and it's happening all here.
Startup Autobahn brings new ideas, new technologies, and also a different approach to many of the topics. It's a very good fit, and we need Startup Autobahn to tackle sustainability.
Big corporates are really hard to get into. It's really hard to navigate their organizational structure. This is what Startup Autobahn excels at.
So the way that we benefited in this program is, of course, by getting access to real data, access to domain experts, and solving a problem that delivers real business value.
you have an open mind, a pioneering spirit, and a technology that has the potential to change the world, you have the potential to change the world together with us. And I think that is what this meeting today is all about.
Progressive and innovative startup scenery
come together to see this innovation platform where startups can shine.
Diverse set of startups, such a great variety ranging all the way from software, AI, databases, all the way to like super high tech.
Open innovation and cross collaboration is the key because the future is at the intersection of material, and this is a dialogue that's unbeatable. And I think for this, Startup Autobahn is a great initiative.
Kind of tied in our daily operations. We know what we're doing, we know that by heart, but we don't really understand what's out there that we do not know yet.
Yeah, for us as ZF, open innovation is so important because it connects us with brains, great talents, latest technologies, and good ideas moving forward.
For a company like ST Microelectronics, we are really keen to be partner here, and we will engage definitely in the future.
We work in a dynamic field of mobility, so we have to keep on innovating to add value to our customers and society.
Creating new markets, shaping new markets, and shaping new opportunities together.
To help our 33 partners to facilitate the Startup Innovation Channel. We are looking for the best startups worldwide for the topics mobility, production, enterprise, and as well as sustainability, and finding the most efficient way and result-oriented way for the collaboration.
All right, ladies and gentlemen, give it up for Saeed.
That's cute. I never heard give it up for Saeed, but we'll accept it. You know, I wanted to welcome everybody. It's really, really fantastic to have you here. But I also would love to ask a couple of questions. Number one, is there anybody for the first time here in Plug and Play? Very few. You have to come more often, please. No, but we have been trying for the last 16, almost 17 years to create like a mini Silicon Valley in this building. We hope that if you're a corporation and you would like to find great technology and startups to complement your business, you could do it here. And to that effect, like the Mercedes CEO, Ola, he came here 7 years ago, and we had curated 3 startups. Frankly, I didn't know who is coming, but they said it was very important. It was Dr. Seche, Ola, all the executive team and the executive board, they call it supervisory board in Germany, and all their country manager, like US country manager, Brazil country manager. So after spending like 4 hours with us here on the second floor, they asked me, Saeed, these 3 startups you showed us, one of them I remember was from Italy. It was material science that you could like grab the steering wheel and raise the temperature of the car or reduce the sound of the radio, and the controls were in the plastic in the steering wheel. And they say, Saeed, we've been trying to develop this technology for 10 years. These 3 PhD Italians did it faster, cheaper, and we now going to license the technology. And they actually invested in all 3 startups before leaving. And then the next day, I got a call from head of Mercedes in Sunnyvale. Is there anybody from Mercedes Sunnyvale here? We need to sort of get them to come here. And they say, Saeed, what was like you were wanting to do? I said, do you want it to be an anchor partner here in Sunnyvale? And then they also asked me to open this office in Stuttgart. Fast forward 7 years, we have done 150 pilots with Mercedes. It's not a big deal, about 20 per year with different business units. The big deal about it is 65 of the pilots are going into production. So we really don't bring technology for the sake of technology to Stuttgart. We first, every 6 months, meet 10 different business units, and we ask them what are their technology needs. And then based on their technology needs, we find the best startups in Israel, in US, in Europe, in Japan. And then if Mercedes is willing to do a pilot, we bring them to Stuttgart for 100 days. And they do a pilot together in 100 days. And the show you saw is the finishing end of the pilot program. So we featured 32 startups in that event. And that concept car that Ola was referring to, the silver car, has 5 startup technologies inside the car, making the car capable of going 800 kilometers on one charge. And after they showcased it at our event in Stuttgart, I think it was June 8, they brought the car to CES. And it was like the highlight of their booth. Again, why I'm saying this is because based on request of Mercedes, Jaguar, Land Rover, Ford, GM, Chrysler, Volvo, SAIC from China, they all mentioned to us, like, we are very happy with what we do with you in automotive. And then we have a mini tier 1 suppliers like ZF, Denso, etc. All the OEM want to be closer to the technology of semiconductor. They would like to specify their own needs. And then in between, they love to work with NVIDIA, or they love to work with Qualcomm or ST Micro especially. But the idea is similar to Apple. They are getting closer to the semiconductor, and specifically Apple is even designing semiconductor and producing semiconductors. I don't think that's automotive industry is going to go that far, but they want to be more in touch. They want to choose the technology they're going to implement their car. And I remember Thierry, the Jaguar Land Rover CEO who introduced me to the Tata Group chairman, he said, Saeed, we looked at our car and we had 120 suppliers of semiconductor. And he said, we would like to reduce this to 10, but have a more capable semiconductor and less supplier customer relationship. We think if we have 10 great relationship, we could satisfy our needs in the semiconductor industry. So if I would love to ask everybody in the room for your help. We would like to make this platform the biggest and the best innovation platform for semiconductor. In this first year, we will work with 40 startups that we will introduce them to the automotive industry as well as the tier 1, tier 2 suppliers. But then after automotive industry, we would like to expand in healthcare industry We have an incredible relationship with Roche Diagnostic, and the CEO of Roche Diagnostic, that we deal with them in Munich, just became the CEO of Roche Global. So we feel we have a good connection with, you know, all the equipment that is used in the hospital that is slowly moving to homes, all the diagnostic and testing. And we would love to play a semiconductor role in you know, diagnostics at home and for the consumers. But again, this platform is yours as much as it is ours, and I would love your help to make this happen. Welcome everybody, and we'll have a great, great program for you, but please spend some time with the startup and the technologies presented here. Thank you.
Thank you, Saeed. And as we mentioned already, we are having this great pleasure to co-hosting this event with CEA. So I would like to ask Michael and Nicholas to come up on the stage and give us like a quick intro of CEA. Please give it up for them.
So thanks a lot. Welcome, everybody. It's a great pleasure, and also thanks so much for Plug and Play to co-organize these events with us. So, as mentioned by Saeed, I think we are a unique moment for semiconductor. I think through pandemic and also last geopolitical evolution, the whole world understood how important is the industry for the economy. There is, I think, a unique and a really prosperous, fruitful collaboration between us, because innovation will pass through ecosystem connection, but also startup, corporate, and also research center working together. So I think we're at a unique moment. EU and US has understand how important is it. You will have CHIP Act also to support, you know, all our R&D effort and activities. So just in few words to introduce CEA. CEA is one of the major research and technology centers in France and even in the world, because we do represent 20,000 people with 5 billion euro of budget, working on defense and security, energy, nuclear and renewables, fundamental research and technological research. Our main mission is to transfer technology to the industry. And if we look at the number of patents we apply for and the numbers that are used or let's say, used by the industry, we rank in the top 5 worldwide. If I make a small dive on our technological research, we are 4,500 people really working for the industry with 1,000 partners. Our business model is little different because we are only funded at 25% by the states. So 75% of our revenue are coming from external partnerships. And we are really glad to work with the top player like ST, Intel, and plenty of others that will come for testimony today. 16% of our budget is invested in equipment because we have a lab to fab approach. We are not university, meaning we need to ramp technology, and we are using proper tools the same as what you have in Foundry today. And last but not least, we have 600 industrial partners a year, so we are really part of a huge ecosystem, and we do set up 6 to 10 deep tech startups per year. So that's obvious connection. We need to work closely with Plug and Play. And I will let the floor to Michael to give you a short introduction of CLAT, which is our semiconductor division within CEA.
Thank you, Nicolas. So first of all, I would like to thank all of you for coming today. This is a big event, a huge event, thanks to you. And do not hesitate to take times to discuss with our senior experts at the booth. We are here with many experts, and you can dig a bit in the technology to understand more. Because our main mission is to create innovations and fast transfer to industry. What does it mean? It means that, and you know that hardware is back, definitively. hardware is back, and it is based on semiconductor. And through semiconductor, your product is unique. You make the difference. The uniqueness is based on the hardware. And I would like to insist on that. And I would like to tell you that through this technology, you keep the control of your IP and your business. So that's fundamental. Then just a few words about our partners in US. You have some track record here with different partners, and we are ongoing on this program, on this partnership today. And I have a short movie just to give you more flavor about our facilities and our program and development. So just a few minutes movie.
CEA Leti's experts support the semiconductor industry in its quest towards ever smaller high-performance devices using the next-generation materials and equipment. Backed by world-class pre-industrial equipment, they offer simulation, technology development, life cycle analysis, and prototyping services. CEA Leti experts leverage a full range of materials using 100mm up to 300mm silicon wafers. They master the entire fabrication process steps, from wafer processing, deposition, photolithography, etching, planarization, and bonding, up to interconnection and testing, including all control steps, reducing industry development time. CEA Leti's researchers create enhanced properties using the Mendeleev's table and disrupt chips architecture to offer unprecedented value in terms of miniaturization, energy consumption, speed, and frequency. Our teams provide 365 nanometer down to 193 nanometer lithography pattern printing services using a world-class immersion scanner. This equipment handles CEA Leti's partners' ever more complex pattern shapes and innovative material mix to achieve ultimate resolution and cut manufacturing costs. CEA Leti is recognized worldwide for its most advanced wafer-to-wafer and die-to-wafer bonding techniques and equipment, allowing 3D integration and high-density solutions. From substrates to components, CEA Leti pioneers high added value and low carbon footprint processes using world-class semiconductor manufacturing equipment. To improve equipment's performances, our teams work hand in hand with suppliers. They ensure smooth industrial transfers with customized ready-to-use multi-step modules that optimize cycle time. CEA Leti continues to install new equipment every year. CEA Leti builds on its scientific excellence to push the limits of miniaturization, leveraging both FD-SOI and gate-all-around technologies. Whether you are looking for computing, power electronics, sensing technologies, or radio frequencies, imagers, and display functions, CEA Leti delivers competitive solutions at various fabrication stages that meet industry high-volume manufacturing lines. CEA Leti's teams turn ideas into disruptive products. Partner with us to fast-track your innovation project.
I just want to point out that when you use your smartphone, inside your smartphone, you have Leti inside, CEA Leti inside. 100% of your smartphone are based on RF-SOI, that's Leti. When you use your smartphone, your image sensors, there is Leti behind. When you use your smartphone with the power management, this is again Leti. When you use an accelerometer in your smartphone, it's based on CEA Leti. So maybe you don't know, but now you know that. So do not hesitate to take time to discuss with the expert. And the first point, we have our huge event, our annual technical review. in Grenoble, I will say the French Silicon Valley, near our partners in Grenoble with ST, Soitec, and very soon with GF. So we have our annual review, so you are welcome last day of June. So thanks a lot.
Thank you. This is working. Yeah, this one is working. Thank you so much. Thank you, Michael. Thank you, Nicholas. It seems that Leti is all over the place in our life, so we need to be more closer to them. So one of the partners that we are really keen to have this partnership with them in the last couple of years is STMicro. They've been engaged with us in a couple of our verticals, in a couple of the locations, and they are helping us very actively in shaping our semiconductor program. And one of the things that we have in common with CEA is STMicro, because they are partner of on the both sides. And I think ST is a spin-off of CEA, right? Kind of. Yes. So, kind of. Okay, very good. So please give it up to John Rossi, the VP of Strategic Marketing of America.
Thank you. So this is just to move forward, yeah?
Yes.
Yep. Good afternoon. Thank you for having ST Microelectronics here. And yeah, we talked about it today. We have a long history with CEA. The start of ST Microelectronics was back in 1986. This is a merger of two semiconductor companies, the French side, Thomson, the Italian side, SGS. And Thomson was part of CEA. So a little bit before my time, but we have a rich history, and we continue that collaboration today. A little bit about ST Microelectronics. We're a European company, 50,000 employees, $16 billion in revenue last year, 80 sales and marketing. We have 14 manufacturing sites. We are some of the rare breed, which we still have our own manufacturing. And I'll talk a little bit, but we're trying to be a very responsible global player in the semiconductor market. ST stands for Life Augmented. Everywhere that microelectronics makes a positive contribution, you have ST. So as CEA was saying, they're in everything. I'd say that because we work with CEA, then ST Microelectronics is everywhere as well. We are built on differentiated technologies. From MEMS technologies to optical sensing, we are focused on differentiated technologies which set us apart in the semiconductor market. It goes from FDSOI to smart power. Maybe you've heard that ST Microelectronics is engaged in several power initiatives, silicon carbide. It happens to be in the press a lot today. ST is there. And along with that, so we have our manufacturing, also our packaging side. These technologies are built into product portfolios. So in automotive, we work on a lot of the microcontrollers and dedicated products, which are in your cars today. Discrete and power, silicon carbide, GaN, IGBT, fundamental to the electric vehicle movement that we're experiencing today. Analog, industrial, and power. Built in with power, we have control, motor control. These are fundamental pieces in working in the industrial market. In our microcontrollers, we have a long history in 32-bit micros. We've been working in this market and growing in this market and have a very good position with our microcontrollers. We also work in security and in connectivity in this market space. On the MEMS and opticals, we have been working in the MEMS market for as long as CEA has been, and if you we're inside all the phones, like CEA. Flight Sense, the optical technologies that we've been developing for range technology and also for vision sensing. And then we've got our ASICs, our basically our core fundamental technologies in building chips, FDSOI, RFSOI, BiCMOS, FDSOI and RFSOI, fundamental with CEA. So again, we have a rich history. One of the ones that I've been more involved in is in FDSOI. We've developed an agreement with Leti and Global Foundries to continue the ecosystem of FDSOI, fundamental to continue this small-scale integration. And we also announced with Global Foundries continued cooperation in FDSOI. So these are really important collaborations. They're important collaborations in France, and I think it makes a big difference for the life of FDSOI. So we work in a lot of these technologies go into our customers' platforms. That's fundamental. Automotive, industrial, consumer electronics, communication equipment. We work in an environment where we are supplying many products to hundreds of 200,000 customers. I didn't want to talk as much about our technology, about some of the responsibility that we have in this market. We announced in 2020 that we made a commitment to become carbon neutral in 2027. This is a small statement, but it has a big impact. No one in the semiconductor space has made as aggressive a commitment. A lot of companies in the world have not been as aggressive. So I'm very proud that we've made this position in our sustainability. So what does this mean? We're working to be carbon neutral. We're working on renewable energy, sourcing 100% renewable energy to get our footprint down on CO2 and improve our use of energy. This is a unique responsibility that we have, not only in manufacturing, but also in the products that we're building. So we have manufacturing sites in Europe and in Asia. We're working to make sure that their carbon emissions, their use of water, are best in class. But now we're looking at the usage of the products that are coming out. How are they used? Are they improving, are they contributing to a sustainable world that we're in? So all of it, we're starting to rate our products now in terms of how they're used and put this rating into use in working with our customers. So we have a manufacturing responsibility. We have, and now we're looking at this usage responsibility. Manufacturing side, again, it's about the electricity we consume, it's about the water we use, the raw materials that we use, where we're sourcing. But then we look at when we're putting something out, how is that used? How is it helping us in sustainability? In energy consumption, 50% of the energy that we consume is industrial-based. The factories that we use to produce everything, it's a big consumer of electricity. If we can improve the efficiency there, it makes a big impact. And so that's why we're focused on this initiative. So I want to talk about two areas that are quite simple but do have an impact. The first one is on electric motors. 70% of all industrial electrical energy is used to power electric motors. So of that 50% energy consumption, 70% is driving motors. We work on variable speed drives to improve the efficiency of motors, and that can create, again, an improved use of energy savings. Motors go into everything we have: home appliances, power tools, robotics, and you can see the market is growing rapidly in this space. Motor control, motor drives, growing rapidly. So if we can enable products in these applications, we're doing good for the environment. One other area which is interesting is in power tools. In 2023, the forecast for power tools is 800 million units. Seems pretty large. Of those, professional use on tools is probably half, more than half of that. So we're looking at installing a MEMS unit that would improve the kickback on a drill. That kickback would then create energy saving. So we're looking in that, and basically in this application, if we were to work on just power drills, again, 360 tons of CO2 in 1 year. Small drop in the bucket, but if we think this way, I think we're going to make a big impact. So semiconductors has a important role to play. So ST is focused on smart mobility, power and energy, connected IoT. We're working on an efficient manufacturing footprint, but more important, we're powering our customers for sustainable innovation. So with that, thank you. We can do questions. Please, Saeed.
What is the biggest challenge you're working on?
So the biggest challenge is the biggest market, or
the biggest opportunity is always the biggest challenge.
Our focus is in industrial markets and automotive. And over the past 2 years, the biggest challenge has been in our supply to our customers. That has been fundamental. As all our supply chains have caught up with the environment, now it's to make sure that we continue innovation with our customers, to make sure that we're doing the best products at the right time. And in those markets, in electric vehicles, that's kind of an easy one as we move from carbon emission to electric vehicles. This is a big impact on our market, and we work on this continued evolution of our silicon carbide to power electric vehicles. On the industrial, it's a wide market, so to be able to supply into those markets is an extreme challenge because it's such small, it's a fragmented market, and trying to solve many problems is a significant challenge. Thank you for that.
Is there any other question? Oh, yes.
Hi, Tahazifi from Amplio. So we work with startups and help them like source some of the electronic components, and I can say the STM32R, like it's basically gold. Like if you could find some like in the market.
Thank you for that.
What would you say? What are the resources that you offer to early stage startups that are trying to innovate, like in the hardware space? Like what should they know about STM in terms of resources or programs or anything that you can do to like help them?
It's a great question. It all comes down to partners. We have a strong internal development, so we have a developer zone on our website, and we enable all the customers with software and applications and boards. That's fundamental. But we have a wide partner network. It's 300 strong all over the world, which adds value to our semiconductors and enables startups to move quickly into markets. So if that really is kind of a two-prong approach. But thank you for that. Yep.
Sure. By the way, my name is Philippe Magashak. I'm also from ST. And the reason I'm here, I'm based in France. And I actually now I'm setting up let's call it more structured innovation sorting process. Let's call it this ambitiously. Now, what this is about is to, precisely to your point, being able as a large and cumbersome and slow company that we might be structurally, and for good reason, to adapt ourselves to agile, small startups that need to move fast and need to decide whether ST is a good partner or not for them. And so we're setting up, a proof of concept lab, essentially, and part of the reason I'm here to identify, partners that could make that happen. Thank you guys from Plug and Play, and moving forward, we believe that we might be, more agile than we have been in the past. Having said that, to the point of John, STM32 is a great platform in terms of being already able to support mass market customers, such as startups, in terms of the everyday usage. Now, if you want to do something more innovative, obviously, then you need the second level of support, which you might not be getting, and that's why we're setting up this kind of second level support. So far in France, but but this is good. This is good. We were just talking about it with John. Here is where all the glamour and the innovation happens, but you're far from the decision centers on a European company such as us. So by the fact that it is based in France, these guys can be the advocates of the startup they work with in here. So I think we're trying to also fix that issue we've had in the past people based here. They were finding great opportunities, but they had no one to speak to back in the decision-making centers in Europe. So anyway.
It is a good answer. Our support is global, though. We do have a far-reaching set of marketing and application engineers, and we do strive to work with all customers, startups included. So thank you for that.
Very good. Is there any other question for Mr. John?
Thank you very much.
Thank you. Thank you so much.
Thank you.
Thank you. All right. So thank you, Mr. John. I'm feeling much more proud hearing all of these things of what kind of partner we have. And without any further ado, I would like to draw your attention to our first deep tech bucket that we are having. I think I accidentally pressed something here. Yes, okay. In the first deep tech bucket, we are going to talk about embedded memories for AI, 3D IC with chiplets, RF datacoms, and silicon photonics. So as I told you before, it's going to be we have a great keynote speaker again, and then we are having R&D technologies presenters from CEA and also our own startups. So please welcome Mr. Umash from Intel. Thank you.
Thank you, CEA lady, for inviting me today. So my name is Uma, and what I want to talk about is even a big company like Intel, how do we work with CEA lady, even at the cutting edge of semiconductor process technology development, where do we see a good fit? What are the kind of things we are doing? And hopefully that'll give an idea to the huge ecosystem, the startup companies here who are actually interested in physically making something and look at Lady as a viable partner. My day job is actually to manage all of Intel's external research. We work with equipment suppliers, material suppliers, research consortia like Ledi, IMEC, Fraunhofer, Lawrence Berkeley National Lab, and so on, for working on what needs to go into manufacturing 5 years from now, right? Not what is actually being manufactured today. So we are talking about something beyond Intel's 18A. Some people call it 1.5 nanometer, 8 angstroms, whatever, right? So that's basically what we are working on. So there's a couple of key messages that I wanted to pass on using this opportunity. One, at a corporate level, there is a pretty big shift in terms of manufacturing, bringing it back to Northern America and Europe. And Intel has actually made a pretty big bet, and and has actually announced a pretty big investment strategy to create a complete chip ecosystem in Europe, not just on the manufacturing side, but actually for people who are familiar with the semiconductor ecosystem, it goes all the way from basic research, right, to applied research, to design ecosystem, technology development, pilot lines, and then HVM manufacturing and and packaging and so on. What we know, we always knew, and we had a long engagement with Leti, is that there are world-class research programs across the European continent. But I want to particularly talk about Leti, right? I think we are making a conscious effort to actually expand our research programs with Leti, primarily in the area of leading-edge semiconductor process and packaging technologies, and I'll talk about some of them. And just to show that this is just not on paper, actually, probably the person who's most recognizable, he's sort of the person who championed Intel's work on high-K metal gate, FinFET, strained silicon, etc. Robert Chow. He's actually moved to Europe to actually really expand our engagements out there. Just a primer for others who may not be involved in the semiconductor industry, right? We heard from the gentleman at ST Micro. So Intel actually is at the leading edge of scaling, right, to really take your transistors to as high performance as possible. So we are in the high performance computing regime. For us, it's all about power, performance, area, scaling to drive all of these leading edge high performance computing and AI applications. Today, we are in the FinFET regime. We've been there for more than a decade. We are expected to be in the nano ribbon, nanosheet regime roughly a year from now, where people might be able to actually source the silicon. But then there are other big bets in terms of how can we continue to scale these transistors. And one of the things that we are and the industry is working on is to really flip it, where your NMOS and PMOS, which have been side by side for 4 decades, now actually have to be flipped vertically, which is what we call 3D CMOS stacking. And also even going beyond that to fundamentally change from a silicon-based transistor to novel 2D-like materials, right? So this is actually a presentation given by Robert at IEDM a couple of years ago, talking about some of the work that we are doing in this area. That is on the front end, right? That is on the transistor side. And then when you look at on the packaging side, packaging is right now going through a huge inflection in terms of how do you, I think I heard 100 different suppliers, I don't know, thousands of different products, but there is a big revolution going on. Some people call it chiplets, some people call it 3D integration, heterogeneous integration, and the concept is instead of trying to make everything on a single chip, can I actually source it from many different companies, many different IPs, but eventually package them so they actually work as one monolithic chip, right? And there's different ways to do it, and I'll talk about some of the programs that we are working with Leti on this front. But the holy grail there is, can you actually do this in a commercially viable way? Because Moore's law has always been about putting everything into one IP block or one chip. If you split them into many, many different chips, can you actually do it? But if you can do it, it actually opens up a plethora of opportunities that people hadn't think about, right? You could combine devices like gallium nitride and silicon on a same stack, which is not possible. You cannot just make them on a same monolithic stack today. So those are some examples. There are products available in the market. One of the first entrants to this 3D integration is the CMOS image sensor, which is there in pretty much all of our phones, right? Where they actually put a combination of CMOS image and a DRAM and a logic driver and actually integrate all of them to actually drive very high performance rather than trying to build them in a monolithic way, okay? So why Leti, and hopefully this relates to some of you, is we have been working with them for a long time. We understand their infrastructure very well, right? One is the talent part of it, and the second part is the physical infrastructure, the clean room, the tools, the materials, the test vehicles that they have, where you could prototype things from the leading edge silicon side all the way to MEMS and other specific functional devices. And they also have a very strong track record of working in the applied research area, where the intent is to really develop manufacturable solutions which can actually go into a startup mode, right? So that's what we are tapping on, and I'll talk about 2 examples. I have 10 minutes, so I want to make sure I stay within my time slot. So one is in the optical packaging. So packaging has always been about copper interconnects, but there is some optical packaging that is actually used in the data center area, but it's still at a rack-to-rack level. The way the direction the industry is moving is so-called co-packaged optics. What it means is that I can have a semiconductor chip, I can have a photonics chip, but then I create an interface for the photonics chip so the external world, the fiber array, can easily connect to it in a cost-effective, high-volume manufacturable process. That's what we worked with Lady on. And the way we work is we know what the problem is. Sometimes we have some ideas, but we take it to them and say, hey, what are the ideas you can come up with, right? Can you figure out an architecture, a prototyping way that can actually demonstrate? And this is a good example of a project that we worked with them where we could actually figure out how to actually do the optical fiber coming from the external world, how to bend it, do it out of plane, and recollimate it and focus it, and do it in a way which very low tolerances in terms of packaging and manufacturing. So Ledi is actually building building blocks for a narrow band demonstration, and the next step is really look at, can this be done for wide band gap? And this opens up a completely different product type where we can bring in a photonics chip closer to the silicon chip, while historically this has never been done. So it's a good example of a targeted program we have done. The second one is what is called die-to-wafer hybrid bonding. I talked about 3D integration, heterogeneous integration. The idea here is you can mix and match different dies from different technologies, right? You can take a 65 nanometer chip and you can put it on a 5 nanometer or 3 nanometer chip. That's what we call die-to-wafer bonding. The question is, can you do this in a very cost-effective, manufacturable way? And for that to do, you really need to drive the alignment to very tight tolerances without compromising defects, velocity, cost, and so on. So again, I think it's a problem that we took to Ledi, and their idea was, can we try something that's completely out of the traditional way of doing it, where we can try some self-alignment technologies. So I won't go into the details of it, but the traditional ways of scaling by making your equipment tighter and just more control is not scalable. You have to try different kind of physics-based solutions. And this is an idea that they came up with in terms of using water droplets to just land them, right? I think as put a die, and then the self-alignment will actually align the top die to the bottom die. So this is another example where they're actually building all the building blocks for the manufacturable solutions, and this is a multi-year program that we have been working on with them. Okay. So my point is, what I'm trying to impress the crowd is, hey, even for a company like Intel, we know what the innovation needs to be 4 or 5 years down the road, and we look for partners outside our own 4 walls. And there are areas where we look at Ledi to expand upon the ideas, come up with their own solutions, and see if they can prototype them so we can assess the feasibility of this. And hopefully that resonates with some of you. Okay. And I'll just recap what I said before. I think there are world-class research organizations and infrastructure in Europe, in particular Ledi, and we are making a focused effort to strengthen our participation and how it can be mutually beneficial for Intel as well as the European ecosystem, and hopefully others can look at similar opportunities as well. Thank you. I can take any questions if there are any.
If there is any questions, yes.
No?
Going once, twice. Thank you. Thank you so much. And as we promised, we are going to showcase the technologies and R&D technologies from CEA. So please welcome Dennis and Eleanor.
Thanks, Rosbe. Good afternoon, and I'm very pleased to start the technical presentation. I will talk about memories, artificial intelligence, chiplet, and 3D integration.
Thank you. Good afternoon. So I will let Denis start, and then I will follow up.
Okay, so let's start with the technologies that are presented on the booth you can find on my left with François and Jeremy about artificial intelligence at edge and memories. The first example is really a very, very nice and good example of technology transfer we've done with an industrial partner, which is Dolphin Design. In CEA, we have a great asset in acceleration, hardware acceleration for artificial intelligence at edge. And we have developed our own technology, which is called P-Neuro, with the differentiating factor consisting of near memory computing. And this is also a block which is based on SIMD architecture, which is scalable. And this block has been developed by us and transferred to Dolphin Design. And we not only deliver just hardware, RTL, but we also deliver SDK, software development kit, and ISS, instruction set simulator, because we also have teams working on software and working on simulation. So this is a complete kit that has been transferred to Dolphin. And this IP, which is called by Dolphin Tiny Raptor, exhibits really, really good performance in terms of latency and also in terms of power consumptions. So that's really, really convenient for IoT applications, which requires very, very low power and very, very quick answer for artificial intelligence. Now, I would like to talk a little bit about another technology, which is about non-volatile memory. So this technology is presented by François, always the booth on my right. We developed non-volatile memory devices, and this development has been transferred as well to Weebit Nano. And we believe that resistive memories are really, really, really good for embedded applications versus when we compared it with the flash, because we have quite a better endurance, 2 orders of magnitude, as well as 2 orders of magnitude better energy efficiency. And it's quite interesting for embedded applications in terms of reliability, in terms of radiation tolerance, and also in terms of programming, and it's quite fast. And if you put together resistive memories with analog cells, for example, the interference is not, we don't have any interference. So that's fine as well for IoT devices mixing together analog and digital. Another topics I would like to talk about, and François will explain much better than me this memory advanced demonstrator. This is a proof of concept platform we use at Leti for our internal development and of our internal research, because we are not only developing resistive RAM, but also PCM, ferromagnetic RAM, and MRAM. And this demonstrators is an integration of back-end offline non-volatile memories technologies on a classical or on an industrial CMOS-based wafer. So it allows us and it allows our partners to develop technologies and to prototype and to make a proof of concept of their memory technologies. And just to end with the memory topics, we have multidisciplinary teams in CEA, from device up to algorithms. And we put all that together in order to co-optimize design and technology. This is what we call DTCO. So we always have in mind DTCO when we develop our research. now, I will just talk a little bit about chiplets. So if you want to learn about chiplets, if you want to know more about chiplets, don't hesitate to go to my booth. This is on my left as well. I will try to explain to you how the chiplets can fill the gaps between, let's say, the theoretical Moore's law and the practical one, because with advanced technology node, we have some difficulties to shrink some part of the chip, like analog parts. And chiplets could be a good solution to replace monolithic die with several smaller dies called chiplets. I will try to explain how it can ease you in terms of time to market and cost-effective development. It could lower the cost for the manufacturing and had really a good flexibility. And according to a presentation that has been done during the chiplet swimming in January here, chiplet could represent around 20% of the market share of semiconductor market share in 2027. So that's something which is quite now important, especially in the HPC world, high performance computing world. So I can give you more details, what we've done, the solution we have chosen for chiplet design, what is our vision for next generation, and just to explain that we have a complete offer, as I said, for the memory, from the system down to the technology. And always on my right, don't hesitate to visit the booth from Aurélie. Without any 3D integration, we will not have any chiplets. So that's really important to understand what we are developing in terms of technology or 3D integration technology, from TSV to propagate signals from top to upper levels for routing, in order to find out the different IOs, connecting and assembly, what do we use in terms of connection between several tiers or layers of 3D integration, and all what is related to rebuild and ceilings. And all these technologies is just not, let's say, a toolbox development. This is also demonstrators. We also exercise, let's say, this technology on demonstrators. We've made a first demonstrator, which is called Intact. This is an active interposer on which we have stacked six chiplets. This demonstrator is now finished. So we have learned lots of with these demonstrators on technology side, but also on design side. We are starting the manufacturing of an optical network on chips. This is another good example because we mix together photonic interposer with 3D integration. And another demonstrator that will start soon is 3D integrated circuits for quantum technologies, because we put together very close, thanks to 3D integration, the qubit silicon, the qubit chip, with the control chip, the readout chip, the one which is called here CRIO-CMOS. And the integration is made thanks to 3D integration. So once again, don't hesitate to visit the booth on my right to learn more about all these technologies.
Thank you, Denis. So I will follow up with another topic about data communications. So here I will introduce two sets of technologies. One is around silicon photonics, and one is around radio frequency technologies. And the booths are in the corner, so do not hesitate to visit us. Eric for radio frequency and Hai for silicon photonics. So you, better than others, probably know how there is a huge demand for high-performance communications, large bandwidth, low latency, low power, because nowadays it's more and more important to have a look at the power consumption of our technologies. And so at CLAT, as it was introduced just before, we have our own platforms for developing our innovative technologies. So we have one 12-inch platform for silicon photonics. This is very state-of-the-art platform with immersion lithography, with a small CD going down to 60 nanometer. And on this platform, we have different tools, really nice tools that we develop through joint collaborations with equipment manufacturers. And so we have a set of possibilities, including nano-imprint lithography, grayscale lithography, and so we have, the sky is almost our limit in terms of lithography. And we have also developed silicon nitride because of its very nice low-loss properties, but also its athermal properties. So we have our own 8-inch and 12-inch silicon nitride platforms. So when our designers have new component ideas, they do very nice simulations about silicon nitride-based circuits. We have the ability to not only make simulation, but also prototype, and at the end test those devices. And what is very important, as it was mentioned before by Dennis, it's also to have take into account the co-design with the electronic, for sure, but also take into account the new material to be integrated in those platforms. So we have this very strong know-how at Leti on bonding materials for heterogeneous integration. And so we use it for many years for 3.5 on silicon integration, for lasers, modulators. And nowadays, we are moving to LNO, BTO integration, as well as also phase change materials for neuromorphic computing based on photonics circuits, and polymer integration for SOH, silicon organic hybrid modulators. But we don't stop when we have an idea and we make the first prototypes. Our aim is really to transfer those innovations into the industry, to you, the startups, the big players. And here we have an illustration of Scintille Photonics, a spin-off of CEA, created 4 years ago. And so they have developed a very nice solution for datacom. This solution is based on 3.5 on silicon integration to really integrate easily and in a scalable way lasers and modulators. So they have made a demonstration 1 month ago at OFC. So maybe you were at OFC and you have seen the demo. So they have showed their first generation of DFB laser array, 4 wavelengths combined on chip. It's with 100 gigahertz spacing. And they have also shown their first DFB laser array product with 8 wavelengths. They have shown the simulation and so it's into production, into prototype pilot line those days. So it will be demoed at the end of the year. And you had a brief overview before of the nice 3D technologies that we can use in our solutions. And so for silicon photonics, we developed TSV, but for photonics. So through silicon via for photonics, in order to enable this nice optical network on chip architecture that is being finalized those days, based on chiplets from ST, 28 nanometer FDSOI, that are then packaged with an active silicon photonics interposer. As mentioned by Dennis, it's very important to take into account from the beginning the co-design with the electronics. And so we have real demos ongoing to show you. And last but not least, about developing solutions based on silicon photonics is that you need also the nice test equipment to be able to measure the good performances of your solutions. So we have best-in-class testing equipment with more than 6 wafer probers in-house. And this year we will have the ability to ramp to a bandwidth measurement up to 110 gigahertz. And next year we have an equipment that will come in for bit error rate and eye diagram measurement up to 128 gigabaud. So we have all the tools from design to prototyping to equipment to develop the latest innovative silicon photonics solutions. And now I would like to take time I have left to talk about radio frequency solutions, because when it comes to communications, you might also look at different use cases, backhauling, networking solutions. And so we have also a very comprehensive set of technologies for radio frequency communications. Here you see an illustration of a lensed array, very directive solution, as directive as a phased array with 30 dB high directivity. But you have a much more cost-efficient solution because you have less active components. You have only one source, and you change your source depending on the reach you have for your application. And then you have a set of diodes, switches, low-cost components. So you have a very low-cost solution, and you have very good compactness in the solution. So you can come on our booth, see Eric to have details on this lensed array. Then you may need also point-to-point communications for the DE band. And here we have developed a channel bonding-based solution. So much better from our point of view than wideband solutions. So you can reach high data rates. Here you see an example of 8 channels. On the top it's 16 QAM, but on the bottom you see a 64 QAM configuration, and you have more than 10 gigabit per second per channel. So meaning for 16 channels you get more than 150 gigabit per second bandwidth. And this solution is also very low power consumption, as we reach only 20 picojoule per bit consumption. So you have a demo on the booth. So if you want to see it for real, come on the booth. And then sometimes you might want more than point-to-point communication. You want longer reach. And so we have developed preamplifiers, power amplifiers based on the CMOS technology, on FD-SOI technology. So we get as good performances as with ASGA technology, but the power of this CMOS-based technology is that you can embed more functionalities. You can embed also power management, for example. Here you see a chip on which you can have not only power amplifier, but other functions embedded. So this is a very powerful technology. And if you associate this technology together with GaN, you can have even higher power modules. And so you have a complete set of material available to reach frequency range 1 or FR2 range with frequencies going up 60 gigahertz, but we even have shown that it can reach 100 gigahertz. So it's a very efficient technology compared to ASGA in the sense of having more functionalities embedded into this RF-SOI technology. And to summarize, regarding radio frequencies, our aim at CEA is really to break the sub-terahertz frontiers. So we have developed CMOS technologies that are off the shelf. You can come to see us. We can customize the solutions for your specific need, but we have solutions in hand already. So thank you for your attention.
Hi everyone, my name is Reza. I'm thrilled to be part of Plug and Play Ventures team. Welcome to our event. So far we had the pleasure to hear from the biggest corporates in semiconductor, including CEA, Intel, and ST. But as our CEO Saeed mentioned, we are an innovation platform. We bring in the largest corporations and the best startups from all around the world. Now let's change our focus from the corporate side to hear from some of the best startups that are addressing similar challenges that the corporates were working on. The first startup here we have Ceremorphic. Ceremorphic has built a new architecture that delivers the performance required for next generation applications such as AI model training, high performance computing, drug discovery, and metaverse processing. They designed it in tune with advanced silicon geometry, and their architecture solves high performance computing needs in reliability, security, and also power consumptions. Please welcome Venkat on the stage to present Ceremorphic. Thank you.
My name is Venkat Metal again. Good afternoon. Thank you all. I'm the founder and CEO of Ceremorphic. So to start with, I want to give some background about the company because you might not have heard about our company because we're a small company. But it's a 5-year-old technology company, and we are a 160-member qualified engineering team. And the Series A funding is all from us. There's no external investor yet. And manufacturing partners, TSMC for 5 nanometer, and TSMC Global for our packaging. Some history about ourselves that I built a previous company, which I sold in 2020 for Silicon Labs. But the important thing in that history is that the previous technology company that I built the technology working for over 15 years, developing the innovation and the differentiation compared to the best wireless company in the industry. And we achieved 26 times the lower energy. The number 26 times is the only one that is important in this slide, because whatever I'm going to talk about next, it has some relevance to this, what we have done in the past. So we are trying to solve the industry problem today in high performance, but every time people, when I say about high performance, can you hear me? Yeah. So what is the requirement for high performance? High performance requirement was there before. People were doing for weather forecasting, medical research, nuclear simulations, DNA sequencing. Computers were there before. What is so important saying that somebody is trying to come up with a new high performance computing? If you really look at the recent trend, everybody understands what ChatGPT and what it does, but nobody knows what is behind it, what exactly happens in the back end. And I wanted to bring that context to explain the requirement for high performance. Otherwise, everybody thinks the same thing, that people have been doing high performance, the same thing is happening. If you look at Microsoft's investment into OpenAI, the $10 billion money is not given in cash. It's given in Azure credits. What does it mean? That means there is a cash in terms of the computing power. That whatever ChatGPT you are asking a simple question, what happens behind in training, we are talking about a huge, huge amount of computational power, energy consumption, megawatts of power. There's millions of dollars going in. So that's the context to tell why that particular thing is important. And if you look at it in terms of the right side structure, this particular cloud infrastructure was there all these years. We all knew how the enterprise companies were built on cloud platforms, and you have your own company. But the ChatGPT layer or whatever the AI infrastructure layer was not there before. Now everybody, you see all the enterprise software companies, partnering with them, working with their open application layer interface and creating companies. So this is the context in terms of what is the real requirement for high performance. I did not yet tell in terms of the problems. So once you have high performance, you cannot get high performance with all the technologies that we talked about so far with a single chip. It's not possible to get that level of performance. So when you had to achieve a higher performance, we all know that we need multiple processors or a high performance processor, all possible combination of connecting vertically, horizontally, systolic arrays, everything we know that. There's nothing new there to go ahead and invent. That's already there in the market. But even if doing all the things is still not enough, you can put a big radical, you can put the biggest chip on the possible, you can do, but still not enough. So what that basically means is you need to connect more and more processing things in a different way, whatever, whether it's a technology that somebody talked about. But whatever you do, every silicon, like human beings, it has its lifetime. It fails in the beginning. It fails during the working. It fails when it ages. So when that happens, Every chip has today that lifetime. When your automotive is working today properly, reliably, people have gone ahead and duplicated and triplicated. That's the reason you can drive safely. It's not that they're not failing. They do fail, but somebody else is taking care of that. Who is taking care of that? The chip designer is taking care of that. But how do you take care of them when you have a massive performance? You have thousands and thousands of processors. You cannot go and do duplication and triplication. There's something called triple modular redundancy that is happening today, but you cannot do that when they're computing that ChatGPT training. You cannot put 3 of them. It's not possible economically. So our company strategy is the straight line. I basically make sure errors happen. We cannot control, but the system cannot fail. That's on the reliability. And when it comes to the energy efficiency, when you have so many processors, obviously, people are talking about putting data centers inside water, taking the energy that computers are going to dissipate to convert them to heat up some cities and things like that. But I'm looking at it in terms of the source. Can we make the energy efficiency at the silicon level? And that's what basically my company does. And again, that's a very big discussion so far, I said, but how do you do it? You can't do that in 3-4 years. A lot of companies are funded with $30-40 million and trying to do these things. It's not possible to do. It's a very big problem. So basically, I spent so far 5 years, 1,000% year effort, and with my own money for 6 years of R&D. And this is what we created, patents around 217. You need fundamental technologies to solve this problem in not one area. You need interconnect, you need memory, you need the computing, analog computing, and your device architecture beyond CMOS. I think one of the gentlemen talked in the past, beyond 1 nanometer. All these technologies, ownership is required to create a product one day to solve this problem. It's not something, incremental problem that we can do it. And how do we do it? In fact, again, all that is still technology, but I did a tape out last year in 5 nanometer. And as you guys all know that 5 nanometer tape outs you don't do lightly. So that's what is done in our company, a small company, we are 160 people. And I'm trying to address the not just a silicon, not just a board, but a complete vertical stack in 2 areas. Again, there are a lot of things we can do, but I cannot do all of them. I took the computing and the drug discovery, and those are 2 things that we are doing. And that's all I have. Thank you very much. And as I mentioned, that I'm looking for partners who could write the next 4 years. I did my own job for 6 years and putting personal money. And we are definitely looking for somebody, very qualified partner who can understand this and partner with us. Thank you very much.
Thank you, Venkat. Next up, we have Techyum. They aim to address the growing demand for computing power in data centers, which has been driven by the explosion of data-intensive applications such as AI, big data analytics, and cloud computing. Techyum's technology has the potential to significantly reduce the energy consumption and cost of running these applications, which also improving the performance and speed. Please welcome Rob from Techyum on the stage. Thank you.
Hello, thank you. I'm Rob Reiner, Director of Product Marketing for Techyum. Techyum's Prodigy family of universal processors integrates the functionality of GPU. Can you hear me? Yeah. Integrates the functionality of CPU, GPU, and TPU into a single monolithic device, eliminating the need for costly and power-hungry accelerators. And it delivers a simple software model that allows homogeneous data centers architectures to be deployed, which makes deployment, maintenance easy, and also portability is much better. In addition, Prodigy's technology addresses the issue in the industry of processor performance plateauing. As process shrinks, the transistors get faster, but the wires get slower, and we're at a point now where wire delays on the chip are limiting the processor performance. So Prodigy's technology is able to reduce the data movement on the chip, which drives up the processor performance, basically keeping the locality of reference, so we can keep the use the same functional unit that produces a dependent variable to actually consume it as well. So we're location aware. In addition, we have a lot of features that delivers cutting-edge performance for HPC and AI, including a wide range of data types, and also that include FP64 down to FP8 and beyond, and also other innovations in AI, including additional sparse matrices over what's currently available. Key features on Prodigy include 128 high-performance 64-bit CPU cores. We have hardware coherency that supports not just 2 sockets, but 4 sockets. So we can create very powerful compute nodes. And on the memory interface, we have 16 DDR5 memory controllers capable of running up to DDR5 7200, along with 64 lanes of PCIe Gen 5. Must have some, yeah, I think I have something embedded in there. So as far as the HPC and AI features, as I mentioned, yeah, we have a range of data types from, sorry about that, that go from double precision down to much lower precision to support AI. And we have emulation for other ISAs. So we can support other, gosh, I'm really sorry about that. So we can support the binaries for x86, ARM, and RISC-V. So it makes it very easy for out-of-the-box testing and evaluation. In terms of target markets and applications, as I mentioned, HPC and AI are key. With our with all of our the features that we've embedded into the device, along with cloud, hyperscale, and edge computing is very, very key. We also, our features also align very well to digital currency, including blockchain. We have large vector unit. We have 2x1 kbit vector units, which aligns very well to the encryption required for blockchain, as well as HPC and AI as well. So we align with a bunch of markets and applications, with our unique architecture. We are pre-silicon, but we've done a lot of simulations, and our simulator we believe is about 95% accurate. It models all the timing and all the memory layers. And so, since we integrate the functionality of CPU, GPU, and TPU, we're able to do very well both on the integer workloads and also on the floating point workloads. So on the integer workloads, we have, we're roughly, based on our simulations, we're about 4 to 5x better than what's currently available. And on the floating point performance, look a little bit more there. So, we're basically, we'll just go back there for a second. Yeah, so we're really, above and beyond conventional CPUs. And we compete with current GPUs. And on the GPU side, we're about 3x, HPC, double precision. And on the AI side, we have a lot of innovations in AI that include advanced data types that go beyond FP8, which is kind of the leading edge right now. And also, we have sparse matrix features that go beyond what the current sparsity definitions are. So it allows us to get even up against the H100, much higher performance both in HPC and AI. Our evaluation platform will support up to 4 cores, up to 64 DIMMs, and next year it's already been announced that there'll be 1 terabyte DIMMs. So we can support up to 1 terabyte or 64 terabyte of memory on a single platform. So that would align very well with some of the AI workloads that require high performance and a large memory footprint. Funding status, currently in the middle of raising Series C. And I want to thank you for your time, and thanks to Plug and Play for the opportunity.
For presenting Techyum. For the last startup in this section, We have Numem. Numem develops advanced non-volatile memory solutions based on resistive RAM. Their solution offer high density, low latency, and low power consumptions, making them applicable for many applications, including edge devices and data centers. Please welcome Jack, one of our French entrepreneurs in residence, on the stage. Thank you.
Formerly French, yes. 1, 2. Yeah. Hi. A lot of familiar faces in the audience. Good to see all of you, and thanks Plug and Play for the opportunity. We've been with Plug and Play since inception and been able to use a flexible model and events like this as well as all the amenities. So appreciative of this opportunity. So yes, we, as you know, and you've heard multiple times today, AI is a big driver and revolutionizing everything, and clearly a huge market for semiconductor, north of $100 billion expected in 2028. And what's important also is that it is a play at the data center, but more and more edge nodes are getting intelligence and driving to add intelligence into the edge nodes at a faster pace than the edge nodes are growing to the expectation of 2.6 billion units in 2025. So a lot of benefits of AI. We all know that. A lot of people talk about it, but unfortunately, it does put a strain, huge strain in compute. And compute, some people, I think it's more intuitive, but memory is just dwarfing it. I mean, if you look at the AI models in terms of inference, it takes a lot of memory to do a good job. And that increases the compute and memory by over 100x. And this at a time where we're all trying to do the right thing for us and for our future generations to reduce the carbon footprint, as well as more and more equipment being battery operated and needing low power. So this is what we focus on, with our angle to be on the memory and SoC subsystem. We bring solutions that are 20x to 290x more power efficient. And we are also providing a much smaller footprint, which can be viewed as a way to reduce the cost, but also as a way to put more memory on chip and not having to go as frequently to outside memory, which is 60x more power. We are providing not the traditional compute in memory, but an SoC compute in memory. So we're building a mini SoC inside the memory data path, enabling further power optimization. And we have patents on all that, and some of those patents apply to MRAM, which is our primary memory, but some of them applies to any resistive RAM. We've taped out to date 35 different chip variants, so we have a lot of experience in getting chips out. Snapshot of our product. We have our memory array, which, as I mentioned, is based on MRAM, but we also have more and more SoC functions built in support of the memory or in support of compute. For memory management and control, built-in self-tests, which can be adaptive. Performance and endurance engine, as you've seen earlier in a presentation, they are the resistive RAMs have traditionally lower endurance, much lower than SRAM, and we're able, with a very small circuitry, to improve the endurance by over 100x, at the same time improving the average performance by about 5x. And then we have compute functions, which are not intended to replace the entire AI accelerators, but as an assist and enabling, again, to reduce the data transfer between the memory and the SoC. So that's in a snapshot what we have inside our subsystem, but we are also now decoupling some of those functions that can work along with other memory IPs or, and different flavors of it, be it RRAM, PCRAM, or even FERAM. So that's our story, and we invite you to join us if you're in the investment community, if you're in the technology community, please stop by our table. We'll be happy to answer any questions you might have. And again, thanks for Plug and Play for this opportunity.
Numem. Thank you guys for staying this hour. We're going to take a very, very short break.
So, thank you very much. So now the idea is to have some more discussions with Ramin. So yes. Ramin, thanks a lot for coming today. And maybe could you tell us more about your background, your personal background, and the background of your team? Yes?
Sure. Thank you. So my background is in the connectivity technology. It's been about 20-some years that I've developed different technologies. I would say at least 3 of them became international standards at IEEE, from PAM4 signaling to Ethernet for enterprise and also Ethernet for automotive. And the last technology that I worked on was about chiplet connectivity that is based on what Elian is based on. And I created 2 companies in the past, VALEO Communications, and last one was Aquantia. Aquantia, we went public in 2017, and in 2018 we were acquired by Marvell for $500 million. My partner, Cyrus Ziai, is also an industry veteran in this field in computer and high-performance computing. And the last company he had, Nuvia, was also bought by Qualcomm for $1 billion a couple of years ago, just before we start Elian together.
Thanks. So then you create your company, your new company, Elian. So could you just tell us more about Elian, about the main mission of your company?
Sure. So the mission for Elian is accelerating and facilitating the adoption of chiplets. And maybe I should explain some background. I mean, the earlier talks also helped a lot to explain this, why we say facilitate or accelerate the chiplet adoption. So for the past 40 years, semiconductor has been around. In the first 20 years of that, from 1980s to early 2000, it was all about building chips of their own function, package them separately, and putting them on the PCB to create a system. Around 20 years ago, people realized that the interconnect between these chips actually are a bottleneck, but if they put all functions on a single chip, eliminate all these bottlenecks of connectivity, the performance goes up significantly. Then that was the era of system on chip, or SoC. And SoC has been serving us very well for the past 20 years, and Moore's Law really helped it. So Moore's Law, pretty much what it says is that every 2 years, you can double the complexity, the number of devices, and so forth on a single chip. So if we took the same chip, waited 2 years, in the same area, we could put twice as much functionality. The performance of that SoC went up. But Moore's Law kind of started to slow it down, and recently they called it the end of Moore's Law, pretty much maybe 5-6 years ago. So what it meant is that rather than being able to fit as much functionality in the same chip, same area, you have to grow the chip size more and more to be able to build stronger and better chips. And recently, last couple of years, it got into a point that the chips became so large that they're not really manufacturable, or if you do, becomes very difficult. So that's started the chiplet era, or system and package era, that every function, rather than being all on a single chip, on a separate chip called chiplet, and all integrated together on the same package. So the key part to it is how to connect these chiplets together very efficiently at very high bandwidth and low power. So that's the mission for Elian, to enable people to do this. And right now, there are, of course, advanced technologies, 2.5D, 3D technologies that, of course, the CEA and LETI working on. And these are all new technologies, and that very select group of companies, Intel, AMD, NVIDIA, have access to, but not everybody in industry. And that has limited a lot of people to be able to use chiplets. So our solution is to provide that solution to a very good high performance, also to a mass market. So on the existing mature packages to offer that. It doesn't mean that
we want to replace advanced packaging, it's just complementary to it. So an existing solution, we can provide high enough performance that majority of the market uses. So that's what I mean by facilitating adoption of chiplets in the industry.
Yes. So as you said, there are many actors on the market. You tell us Intel, you tell TSMC, whereas IP provider like Cadence, Synopsys. So I would like to understand more, what is your business model? How do you manage a room for your company on the market through the chiplet approach? Could you tell us more about your business model?
Yeah. So we develop die-to-die or chiplet interconnect technology that sits on two chiplets that enables them to connect it together. We can offer it in a form of IP on two chips, or also we have chiplet solutions that as chiplet we can sell. And these chiplets can be kind of like an intermediate or a repeater between one chiplet to another chiplet. One example of it is for example, the high bandwidth memory or HBM currently, that it comes or is being sold to the market with a certain microbump solution. And to connect it with another big chip, you need some sort of interposer with advanced packaging. We have a gearbox or a converter chiplet that sits between the two and translates certain interface that needs microbumps to another interface that does not need microbumps advanced technology. So our business is a combination of high performance die-to-die IP and also chiplets, both.
Okay. And can you share with us some KPI, some figure of merit, some key numbers?
Sure. So one of the key advantages of advanced packaging is it provides a large density of wires or interconnects between two chiplets. For example, if you have two chips sitting next to each other with advanced packaging, you can get maybe 1,000 wires connected between the two. With a standard old mature packaging, you get 100 wires. So high bandwidth is important. So if you transmit, let's say, 1 to 5 gig per wire on 1,000 wires, you get 1 to 5 terabits of bandwidth between the two chips. In our solution, we say we provide the same bandwidth, but on standard packaging. In standard packaging, you get 100 wires, but on each wire, we transmit 10 to 50 gig per wire, effectively delivering the same bandwidth of 1 to 5 terabits between the two chips. And the key part is that to do that at same power level that is delivered in advanced packaging. In advanced packaging, 1 to 5 gig type of transceiver, because it's low speed, it's simple, you can easily make a low power design. 10 to 50 gig kind of transceiver is not a simple design, so usually very high power. So our key to fame is we can deliver the same bandwidth at very higher speed per wire, but keeping the power the same. So from outside, you don't know this solution has used advanced packaging or standard packaging because we deliver the same bandwidth and same power. So just rough numbers, we deliver 2 terabits per second per millimeter edge of a chip at a power that is less than half a milliwatt per gigabit, which still beats some of the existing solutions on advanced packaging as well. But of course, on advanced packaging, we can deliver much higher performance, all the way up to 10 terabits per millimeter at maybe a quarter milliwatt per gigabit.
Thanks, very impressive. And maybe I have another questions. What's about the standardizations? Front of the, you know, the standard bunch of wires or UCIe. So how do you cope with these standards?
It's a good question. Actually, bunch of wires was a standard that actually while I was at my previous company, Aquantia, we needed a chiplet strategy. So we started developing this die-to-die interconnect solution that was very efficient. And I was invited by OCP, Open Compute Platform, to present it as one of the options for their die-to-die standard. And eventually it was accepted as the bunch of wires. So it's the same technology that right now we are using at Elion. So to begin with, we started with something that was already adopted as a standard. And luckily, UCIe, which started by Intel, it's pretty much 90+% similar. They took most of the concept from a bunch of wires and applied there. So inherently, we became automatically UCIe compatible as well. So that turned out maybe a bit of luck on our side that both OCP and then adopted it, and then UCIe also followed the same path.
Okay. And maybe now we will switch more on the application side, you know, with the killer applications. Everybody now are speaking about ChatGPT. So could you just help us to understand the link between your solutions and the coming applications, for instance, ChatGPT, artificial intelligence? Can you just tell us and teach us what's the link between your solutions and this killing application?
Absolutely. So as I said, currently we're not yet officially in the market with a product or solution yet. This is the first year that we are starting to rolling our solution. But so as a result, companies like NVIDIA, Intel, AMD, they've used advanced packaging to build these chiplet solutions. And one of the key parts of this high performance compute is high bandwidth memory. It's in fact the memory bandwidth that is the bottleneck for the performance of all these AI systems right now. If you look at NVIDIA GPUs, they're more than 50%, the core itself is not utilized. It's because of memory limitation, not because it cannot handle the workload. So as a result, it's good for, let's say, NVIDIA, because they managed to sell twice as many chips for the same performance, if you would think of it. But for, let's say, hyperscalers like Google, Microsoft, and so forth, that's not a good thing. If they can build their own chips with enough memory, then they can eliminate that bottleneck. One of the limitations for advanced packaging, let's say silicon interposer, is their size. Silicon interposer is a new substrate for advanced packaging, but it's built out of silicon. So its size has its own limitation. So you cannot build silicon interposer today more than a certain, maybe 2,500 millimeters squared. So in that area, you can fit one chip and maybe 6 to maximum 8 HBM high bandwidth memories. And that's a big limitation. If we eliminate the need for using silicon interposer, which is the technology that we have, and we just got the silicon that is working for it, someone won't be limited to, let's say, 4 to 8. They can put 10, 20, 30 of these chips, HBM chips, on a single package. And analysis that we've shown and confirmed, by some of our companies we're working with, it shows about 10x improvement in performance by just eliminating the bandwidth and memory bottleneck in these chips.
Very clear, very clear. And what's about your NU-Link technology compared to the existing one, NV-Link or AMD's Infinity Fabric? So can you give us some comparison? Or?
Of course, what we know about other companies' technologies, to some extent hearsay, and what we hear from other people. But one thing we hear in common from them, and the fact that they're interested to use our technology, is, for example, our power number is 3 to 4x better than the power target numbers, and our bandwidth is at least 2x higher than the bandwidth available. And it's interesting that up to 1 terabit per millimeter, it's something that is limited to certain applications, but for high performance applications like AI and so forth, 2 terabits per millimeter, for whatever reason, we don't know exactly why, but it's a sweet spot. So if you have 2 terabits, you can comfortably eliminate the need for advanced packaging. That's what's available right now, and switch to our solution. But of course, there are also companies that are considering to go to 4 terabits, 5 terabits per millimeter, and they're combining our technology with advanced packaging to get to that level, beyond 4 to 5 terabits at the same time.
Okay, and maybe can you tell us in few words about the automotive applications? What is your mindset and your idea about automotive? How your technology, your solutions can hits the automotive markets. So, and what's about the legacy in the automotive industry?
Sure, it's a good question. So automotive, as we know, we are entering the level 3 autonomous drive, and then level 4 will come in a few years after that, and final level 5. And as we know, these automotive, they call it like data centers on wheels. And they need to have super advanced high performance GPUs and CPUs and storages. One of the key things about automotive is reliability, which is very important. I mean, and last company I was involved with it, at Quantia, we developed the 10 and 100 gig Ethernet for automotive, and realized all the process that we have to go from ISO 26262 and also meeting all the ASIL requirements that in automotive they cannot have. Maybe in a standard chip, 1 out of 1,000 chip is bad or have problems is fine. In a data center, you go and switch, and you pay some cost. In automotive, it should be 1 in a billion that goes wrong, because if something goes wrong that leads into an accident, that's a major thing. So whatever goes to in automotive from reliability point of view should be heavily qualified and gone through years of qualification. The fact that currently the only solution for such advanced processors or GPUs currently is advanced packaging, and advanced packaging from what we hear is subject to maybe in automotive that you have also a lot of vibrations and shakes and so forth. This silicon interposer is a very thin layer, as you know. It's like maybe 50 micron or less than 100 micron. And if something breaks, a TSV, which is very thin, gets damaged and the whole system breaks, it's a big deal. So what we offer them for automotive space is that till that advanced packaging gets qualified and get to that level, we can offer you the quality of the bandwidth that is needed, at least for next generation level autonomous on a standard package that has already been verified. So that's a key value that we bring into automotive, that enable them to use existing packaging technologies that is already qualified, and all the, let's say, pressure would be on us to deliver that performance in already existing, let's say, TSMC process that is qualified for automotive as well.
Okay, and maybe just for the conclusion, what I would like to hear you about the key message that you want to share with the audience. So it's just for the conclusion, in few words, what is your key message? With Eliane.
Yeah. So I think we are at a very important inflection point from when the semiconductor revolution started, when the SoC revolution started about 20 years ago, and right now we are at the revolution like system in package of chiplets. So this is a big shift in the industry, and the whole industry is going in that direction to be able to address the Moore's law and continue to innovate and deliver and meet the performance requirement, because the need is there. The need is going up really fast, but Moore's law is not addressing it anymore. So chiplet seems to be the solution to address this market. And I believe any focus in this front, which is also your company is also focusing on, would be the future. And I hope that more and more people pay attention to this space and basically expedite and accelerate this move into the future.
So thank you very much.
You're welcome.
Thank you, Ramin. Thank you, Michael. It's very fascinating to learn about how chiplet solutions are addressing the end of the Moore's law. It was a very, very fascinating fireside chat. Thank you for that, guys. Today's event is actually our second semiconductor event. The previous event that we held in March, it was mainly focused on the startup presentations. However, in this event, we are lucky enough to bring the whole innovation platform together and have both the startups presenting and also largest corporations in the semiconductor industry present along us. So for the second deep tech bucket, we have presentations on health tech, flexible electronics, sensors, displays, and even energy. Now, I would like to welcome Liho Zhao, Global Head of Personalization and 3D Printing at HP, to present their new innovations in 3D printing of consumer electronics. Please welcome Liho on the stage.
Well, first, thank you. It's really an honor to be here today. But I want to say what I'm going to talk about it is very different from what you heard. So first, the check. How many of you worked with the 3D printing? Yeah, so that's actually says enough how and where we stand, right? So 3D printing as a technology, it was not invented yesterday. It's not invented 2 years ago, many, many years ago. And why we started where we started. So I'll start a couple of examples. So first, HP, founded in 1939. I think in the whole room, everybody knows HP. We always joke in Silicon Valley and many of the companies either affiliated with HP when they started, or have somebody who worked with HP worked in that company. One of the important message our founder leave us is to predict the future, to invent it, and to always create a technology that not only benefits people, but also inspires meaningful progress in a various field. With that energy, and one of the areas I think a lot of people know HP as a PC or personal system company or printing company, and very few people actually also know we are biggest, largest microfluidic company. We have a great fab in our Oregon, Corvallis, and we also develop new technologies that moving us into the different segments. So this is one of them, personalization and the 3D printing. So what our mission, what we're driving, right? We're really driving mass customization and industrial solution. And also for the 3D printing, and mainly we're really talking about the digital, and how do we actually moving those zeros and ones and make that as a physical goods and product. And some of these areas highlighted over here, also example is a sustainable packaging. How do we actually make one of the things, being a flexible infrastructure, having the 3D printer to working on the different technologies and in a different field. And obviously 3D printing, one of the biggest advantage is making the personalization to happen. A great example is everybody, I think a lot of people know, is dentistry for the aligner, clear aligner to correct our teeth, right? So that is solely built and based on the 3D printing because every single treatment are different. So here are some of the portfolios we had, and we definitely had a lot of work going through this. But this is our current portfolio. It's called multi-jet fusion technology with our polymers, and of course metal jet with to making the metal devices. So one of the things is where are these things are using, right? So examples are I just give in a dentistry, and these are even in automotive. And today there's many of devices and started utilizing this technology to build the customized and personalized devices in the vehicles. When we continue working on this, and we had a question, particularly for us, is today we're making all these devices as a static ones. Can we integrate the functions from a get-go? So we have these questions in our mind. Can we actually integrating those sensors and then those electronic devices from the get-go? And similar to the robotics, a lot of these are start having, and one of the problems we're keep hearing is lots of wires going everywhere, right? So how can we actually having those devices made from a get-go or limited certain wires? With all these questions in mind, this is where we actually started talking to CEA back to 2017, okay? Couple of challenges we actually learned from all current prototyping and manufacture process for electrical, mechanical devices or assemblies have inherited design limitation that prevent engineers from exploring the full 3D space. Antenna is one of the example, which we learn a lot from a CEA and from an earlier days. And also, this is an interesting quote, as 3D, our engineers are used to working in 3D, but not our electrical teams. This will be a new way of designing. And these are the challenges, and at the same time, also opportunities. So we kind of, after having a certain discussion and learn from multiple different technologies CEA is already working on, and we had a couple of areas we outlined. We call that 3D for electronics. So one of the things is unlimited tracing, right? So can we not using wire, but build the wire as part of the parts? That's one of the questions that give us opportunity to leveraging 3D space from a get-go. And of course, electronic functionalities, right? So can we integrate the sensors and communication devices or in user interfaces? And one of the things we also talk to ourselves is not only to build those devices, and we don't have to build everything started from a get-go, and we can integrate them. But integrate them in a 3D, that's also a big challenge. And of course, what would be the integrated process looks like? So everything and start from that, and when we're looking at this, what is the underlying technology? We basically created some of the, this is a general multi-jet fusion technology, the powder-based one. So we put not only the plastic materials or polymer materials, but electronic agents to help us build those electronic functions. So at the early stage, we're working with the CEA, so where it's actually something we can build it up to proof of a concept. This is very important. It's great, and it's very easy to have hundreds of different ideas. But where we can really start to benefit and build this. One of the things we worked with is those unique application devices, devices we have, and middle one is really coming the time and during the early pandemic time, these combining sensing and communication, we print 2.5D and a 3D antenna inside of these parts, and we place the chips and sensors, and then the later stage to build that, it's called air pressure sensor devices, and went into the now I lost the words for that ventilator system. Okay, ventilator systems, and of course the other part is how fine the feature we can actually continue building and making the devices. And this is one of the integrated electromechanical devices. Everything today we do on place them on a 2D dimension. What the challenge ahead of us is how do we actually get 3 dimension. So latest the progress, and based on our learning, and we continue collaborating with the CEA on multiple different fronts. And these are the recent ones we actually demonstrated. This is a complicated technology to continue marching forward. So the one we actually had is recent build is 130 different nodes and 47 signals in one device when we actually start building. And of course, one of the things is people always asking, you build your wire in part of your devices with the conductivity, right? I would always counter-argue is how much you actually need your conductivity to be. So nevertheless, and this is one of the important area for the electronics to be really working, and we continue improve our high conductivity in our printing process. And then last and not least is this workflow, right? ECAN and MCAD, how they actually integrated and work together. So for 3D, really to make a difference in this field, and it's very, very important to understand this is not a 1Z, 2Zs. So the productivity, quality, performance, software and data, materials and process innovation needs to continue to happen. This is really just the dream to build. It's not there yet today. And in all these fields, and we continue working together with the CEA as our key collaborators, right? So the most recent one is we were working together on a digital twins to improve our productivity. Of course, materials innovation has always a front and center for all the technology to move forward. With that, thank you very much.
Thank you, Liha, for presenting the new innovative solutions from HP, especially in the 3D printing and personalization. I would like to welcome the CEA team back on the stage to continue with introducing the new technologies and advancement in CEA. Thank you.
Hi everyone, my name is Martin Galzo. I'm with the Silicon Division at Leti, and I'm going to give you an overview of what we do in health, system for health, printed electronics, and finally actuator and sensor. So the activity on health is represented here by Olivier Fuchs, whose booth is over there, and he will be delighted to welcome you and to show you the demo that we have here. So the purpose of the health program at Leti is to see how electronics can help improve human and animal health at all stages of life. There's basically 4 applicative domains. We've been doing that for quite a while. We even have an experimental hospital, meaning real patients in our campus who are treated by a real doctor. There are these 4 domains. So first of all, and that's the oldest one going on at Leti, is medical imaging. So we've been one of the first to pioneer new X-ray imaging solution that everyone in the room has already used today. So these, if you're old enough to remember the old X-ray, you went to the physician and you get a heavy X-ray dose. And for now more than 20 years, this is over, and we're still working on the next generation of X-ray and gamma sources for medical imaging. Second of all, it's more recent. It's been going on for about 10 years. It is medical devices, medical and wellness devices in the form of implantable devices, but also of wearable devices. And also point of care type of application, so miniaturized lab on your lap. Then there is an activity around tool for pharma and biotech. So this involves organ on chip, bioprocess monitoring, and a drug delivery system. And finally, a more recent activity on the environment and the ability to sense and to measure air, water, food, and that's what is especially useful during the pandemic, where we work on a lot of different solutions to actually measure the content of virus in a room. So implant and wearable are the most marketed application at Leti, especially with this very huge program called BCI, Brain Computer Interface, whose goal is and who's actually partially achieved as of today, is to restore mobility for tetraplegic patients. And you have one picture here of one of our most popular patient that has been working with the CEA team. So using this exoskeleton and famous brain-computer interface that allow you to control the exoskeleton through brain waves. On the other example, other extreme of the spectrum, it's a cuffless blood pressure monitoring. So that doesn't sound like, fancy science fiction stuff, but it's actually very useful to have a reliable way of measuring blood pressure. I'm not talking about a way to estimate your blood pressure, which a lot of electronic gizmo know how to do today, but a way for the physician to have a reliable measurement of the blood pressure, and that is cuffless. So it's based on a bimodal approach using piezo ultrasonic transceiver built in thin film technology. Microfluidics is also an area where Leti has several decades track record of developing a system. So the whole idea about microfluidics is to start with polymer and silicon hybrid microfluidic cartridge. So for example, we have developed one for pancreas on chip so in order to accelerate the drug trials for this application. And on another example of microfluidics is a company that was spun off recently that is called Direct Analytics that does a microfluidic device to do a bacterial DNA extraction. So it's based on lens-free imaging, where you basically use an image sensor without any optics, and you slap that in front of the sample that you want to analyze. And with a powerful enough image reconstruction system, you're able to actually count the bacteria or whatever living organism you want to observe here. So it allows for a miniaturized, low-cost detection and sampling of any sort of pathogen. Okay, let me now say a few words about printable electronic and flexible electronics. So this is the area under the control of Audrey and Lina, whose booth is right here. And again, don't hesitate to visit them. So the flexible electronics activity at Leti started 10 to 15 years ago. The idea was that you had this very large-scale integration on a monolithic device, silicon device based on vacuum deposition, ion lithography. So you had this trend going on. And at the same time, there were a lot of applications where you don't need that density, you don't need that precision, but you do need other things that silicon cannot do. So you need, first of all, flexibility. Second, the ability to print on non-flat surfaces, so to have something that is actually conformable, so that follows the shapes of our day-to-day objects, and also the ability to do that at lower cost on materials that can be organic materials, a large variety of materials, and to do that also on a large scale. So that was the initial idea, and the achievement as of today is pretty impressive. So the mission statement is to functionalize large, flexible substrate with printed electronics together with conventional electronics. So it's not one or the other, but you mix the two, and you when you integrate conventional, so let's call it solid-state electronics, you thin down the die so that it gets the flexibility you need, and all the function that where you don't need these monolithic integration, you do them by printed electronics. So the obvious tools is that to combine the two are the pick and place of silicon chips, LEDs, or surface-mounted devices. So the team, the printable electronic team, is capable of the whole chain. So starting from design and modeling of flexible electronic component, developing printable electronic process flow, characterization, so both morphological and electrical, and system integration and prototyping. And by the way, when we say printable, it's not necessarily the screen printing techniques that everyone has in mind. There are other printing techniques that are more versatile than screen printing. So it's screen printing as the basic way of printing, but other more advanced printing are also used in our platform. So this happens in a clean room, the same kind of clean room where you would do microelectronics. The typical substrate is a square format, so it's not a round object there, it's square object. Its size is comparable to a 300 millimeter wafer, and it involves the usual equipment for printing and for coating, thermoforming, so to get the shapes, and back-end equipment. And the nice thing, as I said, is the substrate. The substrate can be pretty much anything. So glass, metal, stretchable plastic, paper. Paper is a very interesting substrate, enabling to do environmentally friendly devices. So what we've done so far is a large portfolio of printed devices ranging from very simple system at the beginning, so capacitive touchscreen, conductive tracks. So the obvious case, for example, in a car is when you need to lay out traces of a signal on a bumper, for example. Antennas, of course, all kind of electrodes, which are nice because when you want to connect with the human body, you don't want to have a flat, solid electrode. You want to have something that is conformable. Also, measuring units, so strain gauge, pressure sensor, humidity and temperature sensor. Also, sensor offering piezo or pyro properties. So they are organic material that have these properties, so you can take benefit of this property the same way you do with a crystal piezo. And last but not least, because I think this is very impressive, all TFT, so thin film transistor display on organic substrate. Pictures, an example below are a PVDF-based printed sensor, an example of multiple sensor on a printable substrate. And here, ECG sensor and respiration sensor combined on a single conformable substrate. So you can see here the actual electrodes of the ECG and the sensing unit that will sense the movement of your thoracic cage when you breathe. Okay, let me end this series of presentation with another type of sensor, the one we call MEMS and NEMS. So these ones are actually closer to the world of silicon chip. Leti has been one of the pioneers of MEMS and NEMS in the 1980s. And since then, we haven't stopped investing on MEMS. So we have a number of world first in the MEMS world. And I'm going to give you some example. And if you want to see a real life example, Sophie, we welcome you at the booth over there. So we have a pressure sensor, for example, that is sensitive enough so that if I get down from the scene and up, it will be able to measure it. Even one step is able to measure, because the pressure on the scene is lower than the pressure down there. Okay, so historically speaking, so it started in 1980. The first mass market MEMS was the capacitive comb-driven detection that was invented by Leti. So it's a capacitive sensor. The way you measure the physical phenomenon that you want to measure is a measurement of a change in the capacitance. So this first invention created lots of different devices, ranging from the accelerometer that trigger the airbag in your car. So that was probably one of the big success, to the inertial sensor that are capable of measuring acceleration in 3 directions, rotation in 3 directions also, and the 3 components of the Earth magnetic field also. In the beginning of 2000, we introduced a new way to sense physical phenomenon, and it's called, we called it NEMS, because unlike MEMS, it involves feature sizes that are in the nanoscale range. So it's still tenths of nanometer range size, but it's smaller than the usual MEMS, which refer to micron size. And this NEMS gauge is based on silicon, so plain old silicon without any change, the one that you find on everyday's wafer. And it involves the measurement of the piezoresistive of silicon. So that invention resulted to actual devices. So as Michael mentioned, ones that are in most of the smartphones that you have on your pocket. And more recently, so starting in 2015 and as of today, we are working on a new concept of MEMS where the physical phenomenon is, we call it optomechanical. And it's actually the interaction between light and matter that we measure here. So it enables a lot more possibility. It also requires manufacturing techniques that are more advanced. So we got to be careful on keeping the cost of this device low, because what created the success in the first place wasn't that much the accuracy of these MEMS, but rather the ability to manufacture them at very, very low cost. Think like, for example, tens of thousands of the device on a single wafer. And this optomechanical detection can be used in area like electromagnetic sensing, frequency conversion, and also lots of other physical, such as gas detection, particle weighting, and whatnot. So to build these MEMS, we have at Leti a number of process module, individual process module that we can reuse from one MEMS to another. And we have also transferred already some of these process modules to high volume production fab. So meaning that if you here have an idea of designing a new MEMS, if there are some physics, some sensing that you want to do and that doesn't exist on the market and you have ideas on that, please come talk to us, and we'll see with you what sort of sensing technology you want to use for that. So the main the process module that we have worked quite a bit are all the piezo material deposition process module based on aluminum nitride and PZT technology. Also, a very important point is the ability to transfer a thin film, and that's one of the unique skills that we have at Leti, is the ability to transfer a thin film from one wafer to another in order to overcome the very common limitation of the thermal budget of a given process. So instead of trying to build, for example, a piezo layer on top of another layer whose process are not thermally compatible, you would develop these two wafers separately and then remove the top film of one wafer and replace it on the other. So it looks very simple when we tell it like this, but it's actually, it involves a lot of advanced process technology on both cleaning and wafer handling. Imagine handling wafer thinned down to tenth of a micron. It's not that simple. The actual resources working on MEMS are 150 plus researcher. We develop all our MEMS on 200 millimeter wafer. However, we have outputted as early as 2015 12-inch MEMS, which are not used in volume production today, but which could become useful one day or another. Okay, so modeling, fabrication, testing of sensor and actuator is what we do at the MEMS lab. And these translate into objects that goes from haptics, so changing your interaction. So for example, having a glass panel and make it feel like it's wood or like it's sand. So we know how to do that. Micro mirror, microphones, ultrasound, piezo, micro speaker, and inertial sensor. There's a whole bunch of possibilities. So again, please come and talk to us. And I'll lead now the floor to Armel, who's going to talk about energy efficient power capture. Thank you very much.
Hi, everybody. Oh, now it works. Okay, I'm going to talk to you about 3 topics. I'm going to talk to you about image sensors, then displays, and then finally energy. So first, image sensors. At the Image Sensor Lab, we have 3 missions. The first one is the design of proof of concepts of the CEA technologies, their assessment, and the exploration of their benefits in image sensors. And for instance, thanks to dense interconnection 3D ICs, we've developed an imager IC that reached 5,000 frames per second. Our second mission is the development of imager and image sensor IP blocks that will boost the performance of our high-end image sensors, of our industrial partners. An example of that is that we developed a 120 dB HDR imager with in-pixel auto exposure. And the third mission is the development of on-chip processing to extract information with unprecedented performances. And I'll give you an example of that in a minute. How do we do this and what makes us unique? Well, thanks to our integrated expertise all along the imaging chain, from imager design to image and AI processing and to compact processing architecture, the Image Sensor Lab features an out-of-the-box mindset while also taking into account the industrial needs of our needs and constraints of our partners. An illustration of that on the right, there's a specific acquisition consisting of a set of black and white images. It's only black, right? It's only white here because the video is not working well. It would then go through a feature extraction on the bottom with the black image, and then it would be fed into a neural network and deliver a face recognition. Another thing that makes us unique is that we are very used to integrate processes, whether from CEA or from other technology labs, and take them as boosting opportunities. I'll give you 4 examples. So the first one on the upper left is SiL. Thanks to a dedicated ADC and a programmable processor array, the smart thermal infrared imager SiL is able to perform various tasks, such as people localization and counting, in just 1 milliwatt. That's 10 to 100 times less than the competition. This circuit is being transferred to a startup. The second example on the upper right is MUWAY, which stands for Microwatt Artificial Intelligence, and it reaches 5 microwatt operation, thanks to the combination of fast scan, a bit plan reading acquisition mode, along with dimensionality reduction and compact inference circuits. It also allows both an autonomous operation and more than 95% object recognition. So this technology has been transferred to ST Microelectronics, and there are still opportunities for collaboration. So maybe with one of you. The third example on the bottom left is about the implementation of complex neural networks. I said I was going to come back to that. So we have designed a chip featuring in-memory computing. It has shown the possibility of implementing 2-stage neural network architecture for only 150 microwatt with an F factor superior to 0.9. And lastly, diagnosis demonstrate the adjustment of wavefront on the fly. Indeed, its pixels perform measurements on the phase of the incoming photons and control the liquid crystal deposited on top, hence changing their phase. So one application is refocus. And the pixel level control of the birefringence opens a large set of applications. So I'm asking you to think about what could your application be with these technologies. And you can come and talk to my colleague Antoine, who is behind you. Now, moving to displays. Display technology is another key component of the development chain at CEA. And CEA is leading the way in gallium nitride-based micro-LED technology for the next generation display components, from the very tiny, think smart glasses, to the very big. So micro-LED is a direct light emission technology, thus potentially much more efficient than the currently ubiquitous LCD technology, which is based on backlights and that are always on. So we work on 4, 6, and 8-inch substrates, and we also have a roadmap towards 12-inch. So from smart lighting to automotive and virtual or augmented reality displays, our R&D spans material, processes, devices, and systems to bring our partners more pixels, higher quality images, and new features like transparent interactive displays. So again, what makes us unique? Well, our experience of integration onto driving backplanes spans many years. And we work with all types of micro-LED and CMOS integration. We can do die-to-wafer hybridization with microtubes with alignment. And here, the feasibility down to 10 micron pitch was shown. We invented a direct metal bonding method, wafer to wafer. And with this approach, we do not need to use alignment. And the feasibility down to 1 micron pitch was demonstrated. And finally, we also work on hybrid bonding, die-to-wafer and wafer-to-wafer, with alignment, where feasibility down to 3 micron pitch was shown. Let me give you 2 success stories on those display technologies. The first on the left. So the CEA developed a micro-LED array for head-up aeronautic displays, an array with 1,700 to 1,200 pixels at a 10 micron pitch, obtained a record brightness of 1 million nits. High brightness is key for augmented reality applications, and micro-LED is considered to be the only technology to respond to the stringent augmented reality brightness demand. And second example on the right, CEA has also demonstrated that a 1 micron pitch is possible, and it's essential for augmented reality. And we have multi-year experience structuring and characterizing micro-LEDs at that micrometer size. So think again about that and ask yourself what could be the benefit of those technologies for your applications. And now I ask you to kind of switch scale and switch gear, and we're going to talk about energy. So we're going to leave the micro scale and the component scale of microelectronics and consider the system size. And by system, I mean think the big data center, think the factory that manufactures those chips. John Rossi from ST Microelectronics made a great introduction on energy. So let's dive into it. You heard a lot about microelectronics today, but did you know that CEA is also a major player in the field of energy? We started with nuclear power 75 years ago, and for the past 30 years, we've also focused on renewable energy. We have a track record of disruptive innovation that we brought to the industry. For instance, on batteries, the major European players are scaling up our technologies for the next gigafactories. And on photovoltaics, the technology that is being produced in Europe is coming straight from our labs at CEA. It's a high-performance silicon heterojunction technology. So now, why does it matter in this audience today? Well, you know better than me that the energy optimization is critical for your industry for 2 main reasons. The first one is obvious, but it's always good to say it, because of climate change and the need to reduce carbon emissions. The second one is to mitigate the risks for your business that are associated with energy. Risk on access to energy, risk on cost containment, and risk for your image, just because of the massive amount of energy demand that is associated with the very high growth of the tech industry. I mean, it's going to require 14% of the global electricity by 2030. So, ensuring carbon-free energy 24/7 for your data center or your manufacturing site or your complex energy system is not easy in a world where carbon-free energy is mostly intermittent, it's in very high demand, and it's costly on yield to store or to convert. So, what if you had access to a decision tool that could guide your energy investment decisions and your control command decisions in operation of your complex energy system? Well, that's why we have designed and created PERSE, which is our proprietary energy optimization tool. It's an agnostic decision tool that is the combination of our very strong knowledge of the physical energy bricks of today and also of tomorrow, and powerful mathematical optimization methods. So with PERSE, you can maximize your energy efficiency while minimizing your environmental impact, taking into account all your energy vectors, heat, power, gas, etc., and all your product flows, including water, which is also getting challenging. And it can be used either in the design phase when you're designing your data center, for instance, or during operations. So let me give you two very concrete examples of results you can get. First, on the left. So this is a large and high-growth industrial partner. Their ambition is to make this specific factory zero emission within 10 years. So the green dot, or it says today, is where they stand today, with on the bottom their expenses, and on the ordinate the CO2 emissions. I said they're high growth, so if they continue, and that's the red dot on the top, their production will increase, and so will their expenses, and also their CO2 emissions. So with PERSE, we propose the blue dots. Various architectures that allow to decrease dramatically CO2 emissions while completely keeping the expenses under control. Let's focus on that orange dot here, that's just below the red dot. For the same expense, as if they had done business as usual, we managed to make them save 90% of their CO2 emission. I'm saying 90%, I mean that's huge, okay, while not spending an extra dollar. And by the way, their energy autonomy with this architecture is increased by 69%. Let me take you to the example on the right, which is this time in operation, so after the design phase. This is a large oil and gas engineering partner, and they want to optimize the operations of green hydrogen production. This infrastructure is composed of a series of electrolyzers, photovoltaic, wind, batteries, hydrogen storage, so complex energy system. And their goal is to maximize green hydrogen quantities, minimize cost, minimize CO2 footprint, and maximize flexibility. I mean, the equation is complex to optimize. So let's get straight to the bottom line. On an architecture that was already optimized in its design, we managed, thanks to PERSE, to gain an additional 10% of green hydrogen produced versus the classic expert laws that are currently used to monitor operations. And that represents a massive additional profit for this partner. So again, my question for you is, what could those gains look like for your energy systems? Thank you. And I invite you to come and talk with us about that. Thanks.
Pleasure meeting you. Thanks. Any question for her? No? Thanks. I just wanted to point out something. I don't know if how many of you have been here in one of our expos or our summit. Very few. I know all of you, by the way. But in June 6th, 7th, and 8th, we have a summit here where, for example, for our mobility and IoT, we have over 200 corporations here. That is from Mercedes, ZF, you know, the many HALA I saw earlier today, and VALEO. But we have all the industry in automotive, from semiconductor all the way to the OEM here. And again, I thought today's comments, especially from different technology from CEA, was very interesting. But the people like from Denso, which is a Toyota supplier of component, they actually have an office here for 5 years. So we had a very little time to arrange this. I really feel if we had 100 startups in the room and 100 more corporations in the room that use semiconductor as one of their component of their product, I think they would truly enjoy being with us here. So my message is, first, we could do a similar event parallel to the summit, 6, 7, 8. On average, we have 1,000 people here every day. And overall, last summit, we had 2,700 people. And 2,000 of them flew in. So like there is about 700 from the Silicon Valley scouting office or R&D office, but about 2/3 of the audience flew in from Far East Europe. So again, as I mentioned, this is very new for us, this semiconductor vertical, but we would love to get your advice and your help how we could make it more effective and more result-oriented and value creation for the startups and for corporations. And again, I did not invite any VCs, but we could have 50 VCs in the room as well. So please help me to do that next time. Thank you.
Thank you, Saeed, for the notes on the upcoming summit. We would love to see everyone back for those events. Now we're going to change our focus one more time and hearing from some of the most innovative startups addressing similar technologies that CEA was discussing and showcasing. So for the first startup, we're going to have SiLC. SiLC Technologies is a silicon photonics innovator delivering coherent vision and chip-scale LiDAR solutions that help machines see like humans. Please welcome Mehdi on stage to pitch and present SiLC. Thank you.
Thank you very much. Well, first of all, thank you, Plug and Play, for the opportunity. It's a pleasure to be here. Thank you. So what SiLC aims to do is to enable machines to see like humans in a cost-effective, power-efficient, compact solution. And we do this by processing the images in the photonics layer as much as possible before the information content in the photons is lost. And we do this in a cost-effective way by manufacturing the complex optical circuits that we need in a silicon photonic chip that we have a proprietary technology over. And we are a component player. We play over multiple markets. And in this area, we have partners who are key market leaders in every sector of the market that we play in. You can see that with some of the investors that have invested in SiLC. So what is the problem we are solving? If you look at what's happening across the world, we are losing about 0.6% of our working age population every year. That is a major loss, and it's even bigger in some of the more industrial countries such as China. And combine this with the fact that as a species, we are getting more and more lazy. We want to work from home, we want to do less physical work. This has created a real problem in the workforce shortage, which is jacking up the cost of labor. And that's a major problem that we have to address. And that has really created an industrial revolution for deployment of robots to replace a lot of what humans do. However, there is a problem here in that the tasks that robots can perform are so far limited to well-rehearsed, repetitive tasks that are usually in a highly controlled environment where they have access to a lot of power and significant computational resources. If you try to put a robot like this in an unpredictable environment such as our life to do a lot of the tasks that humans do, there's going to be significant problem and inefficiencies. Here we need a lot more computational power and we need a lot more energy to run this kind of the existing vision systems at a level to be competitive, and such solutions simply don't exist today. What we need really is something that works like the human vision system. Now, what does the human vision system do and how is it different? Most of us may not know, but our vision system is actually 94% about detection of motion and only 6% about seeing in color. Out of the 100 million photosensitive neurons that you have in your eye, 94 million detects motion and only 6 million detects color. That is what enables us to perform complex tasks, to have hand-eye coordination, and to effectively do smart movements like shooting ahead of the duck, playing sports, driving. All these capabilities are enabled by those motion sensors in our vision system, which our current vision systems don't have. This is a major shortage, and that's why machines today cannot really have the efficiency of humans when they are put in unpredictable environments doing new things that requires hand-eye coordination, complex task performance. And in order to do this, what we really need to do is coherent image processing in the form of FMCW, where you detect motion directly per pixel in the image. And in order to do that, you really need to have very highly complex optical functions, which can only be done in an integrated form for cost effectiveness. And that's what we are doing. The same evolution that happened with radar, we are doing with LiDAR, which is basically has a lot more resolution and capability than radar does. But for this, you need highly integrated chips. That is where we come in. And we have a demo, we have some technology on display here to the right if you'd like to visit us afterwards. So we just introduced our first product. We call it Ionic, which stands for bionic eye, if you like. And this product is capable of a broad range of capabilities. It's by far the smallest product on the market. It has every single photonic function you need on a single silicon photonic chip. We have some back-end electronics with it. And our business model is a component supplier. We play across many verticals, and we sell you this optical module or the digital module, all the other functionalities you need as Lego building blocks, so you can go away and integrate your own system. That's what enables us to play in many markets and pass the aggregate volume cost saving to our customers. So this product is available. You can actually buy it today. And this enables us to play across multiple markets. So we can adjust the system level performance of our product by changing, effectively it's a software defined product. And you can, this graph here shows range versus precision. And by changing the performance of the same product, you actually can play across multiple markets, from high precision, short range applications in industrial and manufacturing, all the way to robotics and a smart life and mobility eventually. And I'll show you some examples of how we perform in those areas. So the first example is comparing our solution with the best in the class on the TOF solution, which is time-of-flight technology. And you can see to the right is the best time-of-flight solution out there, and to the left what we get from our solution. When we optimize our solution for short range, we have a range of about 10-meter capability, a much higher level of resolution and precision down to sub-millimeter level, whereas the best solution out there today is centimeter level and about 2 to 3 meters. And once you take this technology outdoor, the performance drops by a factor of 2. whereas our solution doesn't matter whether you're indoor or outdoor. Another one I want to compare for you is something that we demonstrated at CES. This is the long-range demo. It's about 500 meters. So I went from a few meters to 500 meters with the same technology. And here we are showing a junction at about 500 meters, shooting at it from a balcony outside our suite. And you can see the images we get about 500 meters. Now, that's not the limit. We can actually show you a kilometer, over 1.2 kilometers with the same system. It's very unlikely for anyone to be able to do this level of technology unless they have access to the kind of integration platform that we have. So this is all done, remember, with a tiny, fully integrated chip. So I want to end my presentation here by just re-showing the summary slide, and I'm open to any questions. That's a great question. So we are very active at the moment in warehouse automation, robotics, industrial, replacing human workers that don't exist, basically.
Any other question from the audience? All right. Thank you. Thank you, Mehdi. Next up, we have AmberSemi. AmberSemi uses patented technologies to create a new standard in power management and sensing. Their technology enables electricity to be digitally controlled by software in silicon chip architecture. Please welcome Tar on stage.
Thank you, Saeed, for inviting me. Thank you, Plug and Play. We found a way to control, manipulate, chop, die, slice this electrical sine wave in so many ways, including turning it into a straight line DC, leveraging, in this case, a semiconductor architecture, not semiconductor technology. We actually leveraged off-the-shelf components to do that. So our first breakthrough in this case, which basically we came up with a way to extract DC directly from AC mains by eliminating electrolytics, magnetics, rectifier, bridges, everything else through a tiny, tiny chip. So what we did in this case, we eliminated what you're all familiar with in so many different ways, which is a different products. You see it in, it has it, which is the brick. Okay, we eliminated the brick with a solid state solution. Our solution, in this case, it can be in many applications, in different products. It can be in IoT. It can be a household power supply for other applications. So with that breakthrough, I had no intention of monetizing this because we built it for the purpose of housekeeping power supply for our two fundamental core breakthroughs. One of them is AC sensing. We found a way that we can actually sense, in this case on both sides of our silicon, the line and the load, inductive load, surge, overcurrent, overvoltage, short circuit, it doesn't matter. But what are you going to do in this case when you're sensing if you can't switch fast enough? You're going to be at the mercy of the electromechanical technologies and the speed of the electromechanical technologies that is going to trip. Therefore, we came up with a way, a new architecture again, in driving something like MOSFETs, silicon carbides, GaN, MEMS, in a way where we can be a circuit breaker, we can be a motor control, we can be an outlet, switches, circuit, GFCI, it doesn't matter. Anything replacing relay, 50-cent relay, it doesn't matter at the end of the day. It's AC switching through a solid state solution. So when you see that there's 3,000 times faster, okay, solution, and that's because when we're sitting and waiting to see for an event, we can recognize if that event, in this case, it's real, or if it's just a brand new refrigerator that I'm not familiar with, and now I'm going to trip because I will have to, by the time I trip to the time I'm actually going to open, in this case, it takes about 5 cycles. In our case, we can sit and wait to see if it's going to repeat itself, and if it does, then yes, we will trip, and we can open up, and we're still faster. This is our first demo. When we built the company, before we did any financing, we came up with this particular tiny board, eliminating the brick that I just showed you. And we got UL because everybody's saying, is this safe? It was 1/4 of a 1 watt initially, then we went to 1 watt, and I kept pushing the envelope, then we're up to 5 watts. And scalable technology. We just taped out, and this is what it looks like now. That replaces this, okay? There are no organic materials that are just going to dry up. Where's it going to go? All of the general market, all of the appliances and everything else. Outlets, switches, circuit breakers, it doesn't matter. It's a power supply. But the semiconductor industry is very interested in pairing this with their microcontrollers. And by pairing this with their microcontrollers, now you have AC direct microcontroller, AC direct wireless chips, leveraging their MOSFETs and everything else. So I'm going to go there. I wasn't going to go there, but I'm going to go there. We met with over 100 some companies. We're engaged deeply with many of these companies. Their first reaction, they put their hands on my chest, they push me like this, and they say, you're insulting my intelligence. Okay? And rightly so, they're not familiar with this new architecture. Then when we demonstrate the technology, and I brought what I call it as a Mickey Mouse solution, just to demonstrate it, you can see it. Basically, we brought 110 straight into a tiny board, that board that you saw, 110, AC direct, okay? So what we did now, we said, let's leverage this, and let's go to the AC switching. Look, this is nice. A circuit breaker for a house is very, very nice. But that's not the low-hanging fruit for me. Data centers, hospitals, refineries, industrial applications, all of these different manufacturing facilities, all of those different manufacturing equipment that require circuit breakers in them. Solid state circuit breaker. We built it. We demonstrated it. We demonstrated with our solid state circuit breaker that we can take 10,000 amps to our board, short circuit, and we went because we have speed and we have intelligence. It's not a theory, we built it. Now we're siliconizing it, and as I mentioned, we taped out. So where does this go? Just sky's the limit, that's the AC switching. So my first solution was really the housekeeping for this, but I've decided to monetize it. It's endless. And I will be announcing soon that, it seems like everybody's talking about the automotive. Let's go into the automotive. I'm going to come up with a DC to DC. Let's go from 12 volts to all the way down, and 24 and 48 down without step down. We can do it. We did it in AC. That board that you saw, it can take, in this case, anywhere from 25 volts to 277 volts AC direct. The output, fixed output I have on the first generation, 2 fixed and 1 variable, 1.8 volts all the way up to 24 volts. And now I'm going to scale it all the way down to the DC to DC so I can play in the automotive with you guys. So what we built a circuit breaker. You'll see it over there. We put all the stuff in it. This is not a circuit breaker. When somebody tells me, can you sell this for $10? Okay. They have no idea what they're talking about. This is not a $10 circuit breaker. This is a computer. This is going to be the first line of defense for a building, first line of defense of everything. It has a surge protection, it has inductive load protection, it has everything in there. So this is a computer, what we're bringing relative to electromechanical switching circuit breaker that we are still using now from 1950s. We won last week, we won the Edison Award, 2023 Edison Award. I brought home the gold. We're excited about it. Thank you. Thank you. So, in summary, we built it to demonstrate it so I don't have to teach, okay? Because your inclination typically is you want to go find a whiteboard and you want to teach. You don't want to do that. So you built it to demonstrate it, and we'll go from there. We've won awards. Those are nice because it will drive, in this case, PR to us. It drives investors. It drives partners. This is good. 36, now it's 37 granted patents. We got UL. We have done over 33 successful validations, okay, across the globe with companies in the $100 billion plus, $1 billion, different companies, different needs, multiple needs actually. And we've entered into MOUs and we've been covered by the press. We've raised over $20 million because I'm a serial entrepreneur. I know how to manage money very, very good. And we did all of this stuff with very little amount of money because I want to build value. And now for the first time, I'm opening it in this case to the outside world for investments. I think that's it. Yep. Thank you very much. Thank you, Rossi.
Thank you, Tar, for introducing AmberSemi and showcasing the new technology to control electricity. For the next startup, we have Lumotive. It's going to be the final presentation for the startup sides. Their transformative optical semiconductors are enabling the future of 3D sensing for automotive, industrial automation, robotics, and consumer electronics applications. Please welcome Kevin on stage.
All right, thanks everyone, and thanks very much to Plug and Play and CEA for letting us come here and tell you a little bit about Lumotive. My name's Kevin Camera. I'm the Vice President of Product at Lumotive. Before being at Lumotive, I held a number of leadership roles at Velodyne LiDAR, so I know what the outgoing generation of LiDAR looks like, and I'm looking forward to being part of the next generation of where it's going from here. So who are we? So Lumotive, we're about a 40-person company right now. We're spread out across 3 sites in Redmond, Washington, and in the Bay Area, and in Vancouver, British Columbia. And who we are at the core are an optical semiconductor company. So we're again a semiconductor company first. That's what we do. That's where our core technology lies. And we produce light control metasurface chips that are used for beam steering applications such as LiDAR. There are a lot of other future-looking applications that we can get into, but today, first and foremost, LiDAR is absolutely it. We also provide not only reference designs, but full production-ready processes for fully functional LiDAR sensors to accelerate time to market. So in a industry that's still maturing, such as this, with a new technology, we understand the value of making sure that customers can get their final product into market as quickly as possible and with as little risk as possible. So we really do make sure that we focus on that success. In addition to all that, we also like to advocate the benefits of this technology for the future of LiDAR and the 3D sensing ecosystem. So as we do move into the next generation of LiDAR, the ecosystem is going to look different than it does today. And so we absolutely are active in making sure that we help to promote the benefits of our technology and to help kind of rally and standardize around what that next generation is going to look like. So what do we do? So the LCM technology, you can actually think of it, and I'm not an optics expert, but you can think of it as basically an array of optical antennas that are electronically controlled in real time. So you have incident collimated light and incident beam coming into the surface, and then by modulating the electrical patterns across these channels, you can steer the beam and the energy in any direction that you want. It's a very well protected technology. We have more than 100 patents in the area. And it uses standard CMOS wafer fabrication techniques. There's no There's a very special process that we have, but this uses standard foundries. This does not need the creation of any kind of new fabrication techniques other than using it in the way that we prescribe. And at the end, we use liquid crystalline silicon assembly. And at the end of the day, that produces a single CMOS chip that's capable of performing this function. So here's just a video to kind of to look at it a little bit. You can illuminate the LCM with any type of laser you want. It could be VCSEL, it could be edge emitters, it can even be FMCW. So any collimated light that you get onto it, it will accept. And then again, by modulating that pattern, you're able to steer. Currently today, we're one-dimensional steering. We do have a technology roadmap to go to two-dimensional steering. But it's showing you right now, and to make the video nice and smooth, it's showing it go kind of in one direction. But one of the real benefits of this is that there are 0 moving parts, and so you can actually do random access scanning in any pattern that you like. So it absolutely does not need to be perfectly linear scanning in one direction at a time. So what are we doing? So we know what LiDAR looks like today, right? So we have what started out as mechanical systems. They're still largely mechanical. Even in the MEMS world, one of those M's is mechanical, even though they're very small. So these do mean something is moving in the system. If you look at the other LiDAR, one of the other nodes of LiDAR sensing, you have flash-based technology or flood illumination, and that does extremely well in low cost and short-range applications. So what our technology can do is kind of combine the benefits of both worlds into something that can truly deliver scalable cost, size, and performance, incredibly high levels of integration based on its being completely semiconductor-based manufacturing, and most importantly, new levels of software definability. So there's a very common theme, we just heard about it recently as well, being able to have a sensor which is able to have the software application really control how it behaves to adapt to the environment, adapt to different conditions, track objects, and be dynamic. Part of a fluid moving world is really important. It also allows a single sensor design to be very applicable to a wide range of different applications and scenarios. So this will help drive up volumes, kind of and make LiDAR a much more ubiquitous sensing modality, no matter the application. So what does this next generation look like architecturally for us? So you can see the LCM is a beam steering component, which is accepting the illumination. Light goes out and comes back. It's still a time-of-flight based measurement technique. It comes back and received by a time-of-flight detector. So we do use a TOF-based architecture for the solutions that we're building today. Again, it's completely compatible with FMCW or any other type of measurement of depth sensing technique. And the advantages here is this architecture is 100% all semiconductor. There's nothing that's not a semiconductor-based critical component on that system. There are 0 moving parts, 0 inertia. That kind of helps drive that random access scanning and the ability to not rely on the motion of an object to be able to steer the beam. You can steer the beam anywhere you want, anytime, in any order. Because of the high level of integration, this constitutes a module that's as simple to integrate as a camera. So rather than being one monolithic solution, which requires lots of different calibrations, complicated assembly techniques to make sure that entire sensor is working, this entire module comes with very little calibration required in a form factor that you can directly embed into the end product. Performance is incredibly scalable based on the aperture that you need, based on the amount of light that you can get in there and your system parameters that you're able to, that you need to design to. This can scale from the longest possible range down to the shortest and most compact design available. So the same technology does apply in all these different domains. And again, software definability is a really critical aspect of this as well. So in terms of software definability, this is kind of one of the demos that we have, which is kind of highlighting a use case. It's kind of used very often to highlight it, right? You can, in the presence of an object that you think you need to focus on, you can immediately change the entire scanning behavior of the sensor into a mode that will better be able to highlight the area that you have the most interest. So there are videos like this that other LiDAR manufacturers have put out there. The difference here is that the scanning is truly software defined. This isn't a trick based on you can only do it in one spot. You can really change the actual field of view, frame rate, resolution. Every parameter of the sensor can be changed in real time dynamically. So to kind of just sort of highlight that scalability, we do have products that can scale into any market and any application where 3D sensing is needed. So that can go from the absolute most extreme cases, maybe a defense-based application or long-range automotive, and can scale all the way down to the smallest consumer electronics. Our shipping products, so we do have products shipping now. Volume shipment is this year in 2023. We have a design win with a major industrial customer that we'll be able to announce in about a month. And so these are shipping products that are out there leaving the factory floor this year. And in terms of upcoming products, the next generation for us is even more integration. So if you look at what we have right now, these are module-based designs. The next level of integration is to combine the drivers and the control into one monolithic device that can be directly mounted onto the system. Yeah, so that's a little bit about Lumotive. We've had good success in the industry, won a number of awards, and unfortunately, our demo kits are all traveling the world with other people, but I'd be happy to answer any of your questions at the booth right over there. Thank you.
Thank you, Kevin, for presenting Lumotive. That wraps up the last tech bucket for today. Now I'm gonna give the stage back to CA team Nicholas to take over. Thank you, everyone.
Okay, so it will be the last session of the days, 2 more presentations. The first one, I will ask Martin, who is the French economic counselor for the West Coast, to come to explain how to work with France, but also to give us, a teaser on EU and National Friendship Act. And second, will be VALEO. VALEO is one of the key players in France, tier 1 key players, leader on ADAS, and also on EV powertrain. So it's a huge new application for semiconductors, and really interesting to have Gonzague on the stage. So Martin.
Yes, hello everybody. Yeah, so thank you for giving me the floor, and I'm really excited to see so many people that are actually interested in the deep tech French scene. So thanks to the CEA to organizing in partnership with Plug and Play this fantastic event. So I'm not a technician. I'm a member of the Ministry of Finance in France. So I'm not going to talk about techniques. I'm going to talk about public policies and why you should reflect on choosing France for maybe your next investment for coming to Europe. I know it's been a long afternoon, so I'll try to be quick. And I'll start with a glance at our economic situation and what are the opportunities in France. So let me recall that since 2019, France has become the most attractive country in Europe for foreign direct investment and has remained at the top position since then. So it's more than 1,700 foreign sourced investment that were undertaken last year in France. Obviously, the US has a very special position as it is the first foreign investor in France with close to 300 projects every year. For example, you might know or recall that GlobalFoundries, one of the major semiconductor actors, in partnership with ST Microelectronics, has announced last year a major investment of $6 billion to establish new chips manufacturing capacities near Grenoble, so near where the CEA is based, actually. R&D investment are very dynamic as well, thanks to our strong R&D tax credit, which, if I quote the OECD, is one of the strongest in the world. And so we have almost 200 projects every year. And giving you another example is Qualcomm, that has just reinforced its R&D capacity last year by opening a new R&D center in the Brittany region. So obviously those figures are outstanding, and as a French policymaker, I'm pretty proud of them. But most importantly, I want to tell you that what's important is that the senior executive of foreign businesses established in France are very satisfied. More than 90% of them are very satisfied with their investment and do plan to expand their activity in France next year. Meanwhile, I have to say that our economy remains strong in Europe. So last year we reached a economic growth of 2 plus 6%, which is much higher than Germany. Our inflation remained quite low, thanks to very strong public policy implemented to keep energy prices low, including for businesses, and our economy keeps creating jobs. Obviously, France is attractive because it has strong assets, something that I would like to highlight. First, we are the second largest consumer market in Europe, and with a natural position in the center of the country, and so we are the natural gateway to the biggest single market in the world, with 500 million consumers in Europe. And Africa as well is just on our doorsteps. Second, we have very high quality infrastructures in which we keep investing, and like roads, fast trains, telecommunication, and so on. And so that's, you're in the center in Europe, but you can reach all our partners very quickly and in a very convenient way. And we have very high-level universities and very strong workforce. For example, did you know that we are just second after the US when it comes to the number of field medals, the equivalence of the Nobel Prize for mathematics. And last but not least, I want to say that our energy is largely decarbonized thanks to our nuclear power, and it's one of the most competitive in Europe. So those are very key assets that you should know. Nonetheless, we know that those assets, natural assets, as I would say, need to be strengthened, and we have undertaken a series of pro-business reforms. Maybe, well, the last one we have undertaken has echoed to here, but just recall some. We have adopted an unprecedented tax cut for businesses. And for example, our corporate tax rate has fallen from 33% to 25%. So which is actually the European average. And fun facts, now if you have a corporation in France, your net incomes are less taxed in France than in California. So that's something you should have in mind. I wanted to highlight as well that we have implemented many specific tools for our startup ecosystem. You know, our president pledged to make France a startup nation and to have 25 unicorns by 2025. I have to say that we have over-delivered, let's say, because we have now more than 30 unicorns. And last year, even with the downturn, the economic downturns, our startup ecosystem managed to raise an historical amount of $13 billion, and half of it coming from the US. So our ecosystem is getting traction, including here in the Bay. And just a quick word, because this landscape would not be completed without talking a little bit about our forward-looking plans called France 2030. So before adopting this plan, we already, getting out of COVID, we have voted and implemented $100 billion relaunch plan to boost our country in the post-COVID environment, to make our economy more reliant, more competitive, and less carbon intensive. And this plan was pretty effective. Paul Krugman, your Nobel Prize economist, said that we had one of the best post-COVID recovery. So France 2030 is actually the prolongation of this relaunch plan and is conceived to direct our economy towards the most promising industries. So with an additional $60 billion, France is on track to becoming a world leading country in 10 strategic sectors. They are all listed here, so I'm not going to go into a deep dive on each of them. And I just want to tell you that on top of this amount, we have $2 billion dedicated to adapt our workforce skills to the need of those new industries, which is quite impressive as well. But I will just take a deeper dive into our relaunch plan on microelectronics, because it's obviously of particular interest today. This sector has a large chunk of this allocation with $5 billion dedicated only to enhancing and fostering our already well-established electronic industry. We do estimate that with this public money, we will be able to leverage around 10 billion in private investment in the year to come. So obviously, part of this is channeled to R&D and to bridge the gap between lab and fab to enable new technology to emerge with the CEA, and especially in fields like telecommunication and green transition. This plan has already convinced a major player to choose France. So I just recall briefly the above-mentioned Global Foundry and ST Microelectronic Investment. But we have Intel that has well announced a massive investment in R&D, in high-performance computing and AI. And we do expect in let's say, the few years to come, at least 10 additional factories to emerge from this plan. And as it's just been adopted, and it's of pretty much interest here, last week the European Chips Act was adopted. So it's going to be published in the official gazette pretty soon. But it's a major step in our strategy, European strategy, to reassure production capacities of chips in Europe. So you should know that it's equal to size to the US Chips Act with 40 billion euros. So it's around 50 billion US dollar. And around 10 billions are dedicated to R&D, and the rest is dedicated to grants for manufacturing capacities. So in a nutshell, if you're considering to invest in Europe in chips and microelectronic, I think it's really the right moment to decide and to act, because you can benefit both from national and European plans. So last but not least, I just want to briefly introduce you to our team France in the Bay. I am myself, as Nicolas said, representing the Ministry of Finance. So if you have any question relating to regulation, economic regulation, please reach out to me. And I can also enable high-level meeting with our ministers in Bercy, but far beyond with the whole government, or any other high civil servant that can help you to settle in France. I work closely with Business France, so I know that we have some colleagues in the room here, if you want to exchange with them after the meeting. And they actually provide a tailor-made service to any foreign-based entity that want to increase or settle any line of business in France. So depending on what you want to do, they will help you to find the best French hub to settle in, connect you with the right authorities, whether at national or local level, and that will simplify pretty much your landing in France. Talking about economic development at local level, be aware that France has 13 regions, so that would be the equivalent of your 51 states. And they are the ones that are actually normally dedicated to economic development. 13 of them, they have all different tools to attract you and convince your corporation to land in one of their communities, such as tax incentives, grants, or loan. I just want to quote, say one, which is the Aura region, Auvergne-Rhône-Alpes, because the CEA once more is at the center of it, and because it hosts our French little Silicon Valley. It's actually the French first industrial region, and is home of one of the major deep tech cluster that is called Minalogic as well. So I will give the floor now to Gonzague at VALEO, but just one quick word to conclude, and really to encourage to foster our bilateral deep tech cooperation. The challenges are so big that I believe that no single country will be able to solve all those technical challenges by itself, and that the like-minded have to work together. And so, when we make such events like today, we know that we are on the right track to do so. Thank you very much.
Thank you, Martin. So thank you thank you, Plug and Play and CEA for inviting me. So I wanted to come and deliver you an outlook on VALEO ADAS, on where we stand. ADAS is right now an exciting environment, a fast-moving market, and I wanted to share where we stand on VALEO side. So I will start with two slides to share VALEO at a glance. So we have 4 pillars of activity. The first one is electrifications. We deliver the complete suite of technology to power the EV. So from onboard charger, inverter, e-motor, and we have a partnership at component level with CEA in this field. On electrification, we also deliver the thermal chain, which means the plates to heat the battery pack, to cool the battery pack, but also the heat pump. So the EV has many impact on the vehicle. So entire new product are entering the car like heat pump. The second pillar is ADAS. I will come back to it. The third pillar is the interior experience that is being reinvented. So we have sensor detections, we have interior detections, so we are implementing driver monitoring product, radar detection inside the vehicle to monitor the occupants. And we see as well screens growing in size, growing in content, and this is a growing field. And the last pillar of our activity is lighting, so lighting inside the car, lighting outside the car. So in a nutshell, VALEO today, we are a 110,000 people company. We are 16,000 in North America, and we have opened our office in the Bay Area 7 years ago. We are doing here both research activities, but also customer application project. We all see the automotive field merging with the tech field, and the, let's say, the automotive industry is growing in the region. So now with this introduction, I would like to focus on ADAS, what we do, where we stand in ADAS, to give you this outlook. So to speak for ADAS, we need to start with detections. We need to start with sensing. So ADAS is all about implementing the different waves, the different technologies to detect the surrounding of the car. So we have, at VALEO, we are proud having the strongest or widest detection portfolio in the market. Starting on the top left with ultrasonic sensors. So it's a piezo and an aluminum membrane vibrating and sending ultrasonic waves for the near field. We have also a viewing camera using and growing in megapixel. We are now we will launch the 8 megapixel camera application. We have pre-development as well in the near field. We have pre-development is near field radar and near field lidar. So this is for the surrounding. This is for the surrounding of the car. Now when we look forward, we have the rain light sensor to provide these informations. We have also the front camera, and here we are a scale-up marker to Mobileye. We have been able to deliver 10 million front cameras so far. So this is to be correlated with the viewing camera. We have delivered 100 million viewing cameras so far, and we have delivered 10 million front cameras so far. And the two technology I want to introduce, this is the mid-range radar that are the well-known 77 gigahertz radar. And of course the LiDAR, that is a growing field by now. So I will make a focus on LiDAR. So we have launched our second generation in 21. We are proud having been the first one to launch an automotive qualified LiDAR in the street. We have announced recently that we will launch our third generation with Stellantis in 24. And we have also announced recently that a robotaxi company have selected the VALEO LiDAR. So we are very proud about our strong LiDAR position, and our third generation will reach the streets next year. Now, I shared about our sensor technology, but once we have all those detections, we need to embed them. We need to fuse them. And for that, we are developing a portfolio of ECU, of control units. The control units that we are bringing to the street are liquid-cooled, and we are making sure that both our software and hardware architecture are able to adapt the different SoC that we are developing, that we are using. As example, we will have our first SOP with a Qualcomm SoC next year at BMW. This will be a liquid-cooled ECU to support the driving feature level 3 of BMW. We are also a scale-up partner to Texas Instruments, NVIDIA, and Qualcomm, as I said, to embed those SoC in the vehicles. So now I spoke about our different components. So these are the different components that we use in our portfolio with the target to bring system and function in the car, system and function in the vehicles. So now when we speak about functions, it means at first we are bringing together all those detections into a fusion map at object level or at raw data level. And we have built different platforms to be able to use the sensors that are embedded into the vehicle. So the first platform is the computer vision platforms to extract objects from our image. Then we have the surround view platforms, that is our second software platforms, to be able to deliver the visualizations to the driver. Then we have the parking platform that is delivering the feature, allowing the vehicle to drive itself. And last but not least, the active safety and the driving platforms. All those feature layers are using the inputs from our sensors and are also hosted in the controllers I was introducing earlier. So this gives you the overall architecture overview. Then I'd like to go at feature level. So this is the feature we are bringing to the market, bringing into vehicles. So on the far left, the parking features to allow up to level 4 parking to go from full auto parking to valet parking. Then the active safety platform that is delivering all the NCAP features from emergency braking, lane keeping, traffic sign detections, and then the driving platforms. So we are bringing as a system up to level 2 plus towards OEM. And in parallel, we are proposing our technology as components to support the level 4 applications. Maybe as hardware components or maybe as a software components with localization modules, with data fusion modules. So with these targets, we aim at being an enabler of the new mobility. So on the left side, coming to OEMs, offering our component and systems. And on the right side, going to new mobility players, maybe robotaxi, maybe robot droid, to come with components at detection level or software bricks. In a nutshell, and to share you numbers, so we've been in this ADAS field for 30 years now. So we have launched our first parking application in '91. We have been delivering 30 million sensors a year since the year 2020. And once every 3 cars is using a VALEO ADAS system today. So we are proud of this achievement, and of course, I think this is also an ecosystem activity. So I was very interesting to hear from Ramin how the chipset will help us to make the next step, because this is a very fast-growing market, and we are still at the beginning. So thank you for your attention and for your time today.
Okay, so thanks a lot, Gonzague, for this last presentation. Before starting the cheese and wine, I would like to thank all the people, which come today and stay all the afternoon with us. I think you are all convinced that there is huge opportunity for innovation in semiconductor. And I will ask Saeed to come to the stage for the closing remarks. And then in 2 to 3 minutes maximum, cheese and wine, as we are French people. We'll be really glad to share cheese and wine with you.
Thank you so much. It's a great to do this event with you. As always, I have an ask. So just we have a very large French group here, but as a plug and play, we would love to expand more in France. I believe we are opening an office with the race car company Le Mans, similar to what we did in Stuttgart. But in principle, we have about 120 portfolio companies in France, less than, I would say, 6-7% of our overall investment. But I thought I'd share a fact with you because you shared a fact about French unicorns. We have 34 unicorns that we were seed round investor in. Like the best ones are Dropbox and Honey or Lending Club. But we really would love your help to do more investment in France. And more importantly, especially for B2B businesses, automotive businesses, technologies like semiconductor, we feel we can take them global. We think we can bring them here, which some of the excitement of the market is here. We always urge to our startup, please stay where you are. Here you cannot find employee. It's very expensive to compete with Google or Apple. So, but we think they should have a presence here, and they should do business development here and funding here, and maybe a little bit of innovation. So we would love to build the bridge with France. We would love France to be one of our top 5 countries we are active in. And again, we look forward to doing it together with everybody in the room. Thank you so much. Thank you.